Hello there, and welcome to Life Beyond Seen, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we are drifting toward a river that, on paper, can look almost straightforward. It has a name, it has a shape, it has banks, bends, tributaries, villages, rapids, ferries, fish, mud, rain, and maps with neat blue lines. It sounds, at first glance, like something people should have figured out by now. After all, humans have crossed oceans, climbed mountains, flown above jungles, and placed machines on worlds that are very inconveniently far away. So you might reasonably assume that a river on Earth, no matter how large or wild, ought to be something we can fully explore with enough effort, enough equipment, and enough determination. And yet the Congo River has spent a very long time reminding us that a line on a map is not the same thing as understanding a place. It is one thing to point at a river from a comfortable chair and say, there it is. It is another thing entirely to enter it, follow it, measure it, survive it, interpret it, and claim with a straight face that you truly know what is happening in its depths, along its banks, beneath its surface, within its flooded forests, through its violent currents, and across the vast human and ecological world that surrounds it. The Congo is not just water moving from one place to another. It is distance, force, weather, biology, history, isolation, uncertainty, and scale all tangled together in a way that makes easy understanding almost impossible. That is what makes it so compelling. Not because it is mysterious in a dramatic storybook sense, with every bend hiding some convenient movie villain or glowing treasure chest, but because it is real, physically real, stubbornly real, and so difficult that even modern technology often arrives with great confidence only to discover that confidence is not the same thing as control. Boats can travel parts of it. Scientists can study parts of it. Local communities know parts of it with practical, intimate expertise that outsiders often underestimate. Satellites can look down, instruments can be lowered, expeditions can be launched, papers can be published, documentaries can clear their throats and prepare to say something grand. But the full river, as a living system and a navigable reality, keeps resisting the neat, complete version of itself that we would very much like to have. So tonight, that is where we are going. Not into a tidy tale of heroic conquest, and not into one of those stories where modern tools arrive, some dramatic music swells, and the narrator informs you that everything has now been solved by a drone and a man in a beige field vest. The Congo has embarrassed that kind of certainty before. What we're looking at instead is why this river remains, even now, one of the hardest places on Earth to fully explore in any total sense. Why depth alone is only part of the problem. Why jungle is only part of the problem. Why danger is only part of the problem. Why even the idea of exploring it becomes more complicated the longer you think about what that word really means. Because perhaps that is the first difficulty. To explore a place, do we mean passing through it once? Do we mean mapping it accurately? Do we mean measuring its deepest points? Do we mean understanding its ecology, its seasonal changes, its currents at different depths, its sediment loads, its fish populations, its hidden canyons beneath the surface, its relationship with the people who live beside it and depend on it? Do we mean producing a complete picture that remains true next year, and the year after that, and during flood season, and in drought, and in places where access breaks down, and in regions shaped by conflict, infrastructure failure, or political fragility? A river like this has a way of turning a simple verb into a very long list of unfinished tasks. If you're listening from somewhere dry and quiet tonight, perhaps from a bedroom, a sofa, a train seat, or the familiar little nest of pillows that seems to grow more persuasive the later it gets, I wonder where in the world you are right now, and what time is it in your corner of it. It feels oddly fitting, doesn't it, to think about location at the start of a story like this? because the Congo River is one of those places that makes position matter, not just where it is on a globe, but where you are in relation to it. Far away, it can feel almost conceptual. A bold geographic feature in Central Africa, a famous river, a point of reference from school atlases and wildlife documentaries. Up close, that illusion evaporates rather quickly. Up close, distance becomes effort, weather becomes a schedule problem, water becomes force, and the green edge of the forest stops looking decorative and starts behaving like a barrier. If this gentle deep dive is the sort of thing you enjoy, whether to unwind, to learn a little, or simply to let your mind idle somewhere far from the usual lists, alarms and unfinished messages, I would be ever so grateful if you gave the video a like and maybe subscribed. It helps this quiet little corner reach more people who enjoy drifting off with strange questions and stubborn facts. And tonight's question is certainly stubborn enough to earn the trip, because for all our talk of exploration, for all our confidence with maps and machines and measurements, the Congo River remains one of those places that asks humanity a very direct question in return. You say you want to know me. Fine. How much work are you really prepared to do? That, in a way, is the tone of the whole subject. The river does not cooperate just because curiosity is sincere. It does not reveal itself because equipment is expensive. It does not become simple because a satellite image makes it look like a broad blue ribbon looping neatly through green land. Seen from above, large systems often appear calmer than they are. A storm viewed from orbit looks almost elegant. A glacier can appear still. A desert can seem empty. The Congo teaches the same lesson. Beauty from a distance does not mean easy access on the ground. A clean shape on a map does not mean manageable conditions in person. A river can be visible and still remain deeply, stubbornly ungrasped. Part of the reason this particular river unsettles neat explanation is scale. The Congo River is not merely long, it is powerful, immense, and tied to one of the largest rainforest systems on Earth. It drains a colossal basin. It gathers water from an enormous region. It behaves not like a simple route through a landscape, but like a system woven into climate, forest, rainfall, soil, wildlife, and human life at a huge scale. Even that description risks making it sound organised in the sort of orderly way that textbooks prefer. In reality, scale does not arrive politely. It arrives as logistical strain, as changing conditions, as travel that takes longer than expected, as instruments that behave differently in difficult water, as stretches where one kind of vessel works and another does not, as banks that flood, forests that close in, and channels that are not equally welcoming even when they appear to belong to the same river. And then there is the matter of depth, which has helped give the Congo a reputation that sounds almost exaggerated until you look more closely. There are places in this river that are astonishingly deep, far deeper than many people expect a river to be. Not a lake, not a trench in the sea, but a river, a moving, dynamic river carrying immense volumes of water over complicated underwater terrain. That alone would be enough to complicate exploration. Yet depth does not act alone. Depth meets current. Current meets turbulence. Turbulence meets sediment. Sediment meets visibility, instrumentation and interpretation. Add remoteness, add weather, add infrastructure problems, and soon the idea of just find out what is down there starts sounding less like a practical plan and more like something muttered by a person who has never tried to lower scientific equipment into violent moving water while surrounded by jungle and uncertainty. There is also a quiet habit in many discussions of exploration, and it is worth noticing early, because the Congo punishes it. The habit is to imagine that a place becomes known the moment outsiders arrive with technical language. But rivers are not blank before science shows up. The Congo has been lived with, travelled, fished, crossed, named, feared, respected, worked, and remembered by the people along it for generations. Knowledge exists in different forms: navigation knowledge, seasonal knowledge, risk knowledge, practical knowledge, local ecological awareness, all of these matter. The problem is not that the river has been invisible to humanity until modern researchers appeared with clipboards and sonar. The problem is that different kinds of knowing a place do not automatically combine into one complete, stable, universal understanding. The Congo remains difficult not because no one has ever known anything about it, but because total understanding is a much taller order than most words like explore are willing to admit. That is where things begin to get especially interesting, because at first the challenge sounds geographic, a hard river in a hard environment. Fair enough. But the longer you stay with it, the more the challenge expands. It becomes technological, ecological, social, political, historical, and even philosophical in a very practical sense. Not philosophical in the floating clouds and wise eyebrows manner, but in the more grounded sense of asking what counts as mastery, and whether some places are simply too changeable, too layered, and too resistant to be wrapped up into a clean package of human knowledge. The Congo does not just resist movement, it resists simplification, and even its image in the public imagination has often been warped by distance. Many people know the Congo as an idea before they know anything solid about the river itself, a place of jungle, a place of remoteness, a place of danger, a place mentioned in tones that are either too dramatic or too vague. That can create a strange double error. On one side, there is sensationalism, where everything becomes exaggerated into a feverish legend. On the other side, there is flattening, where the entire river is reduced to a fact or two, perhaps its depth, perhaps its basin, perhaps a sentence about biodiversity, and then politely filed away as understood. Neither approach does the river justice. One turns it into fantasy, the other turns it into trivia. The reality is harder and more interesting than both. A river like this can be crowded and isolated at the same time, useful and dangerous at the same time, familiar to those who live with it and still opaque in wider scientific terms. Parts of it are central to transport and daily life. Other parts are punishingly difficult. Some stretches invite movement, others seem to resent the suggestion. In one place the river is a road. In another it is an obstacle. In another still it is a living puzzle whose deepest structure remains only partly resolved even after repeated study. That is not the behaviour of a simple feature of geography. That is the behaviour of a system large enough and forceful enough to keep humbling every attempt to summarise it too neatly. There is something else too, and it often gets overlooked because it sounds less glamorous than deep water and hidden creatures. Exploration depends on maintenance, on fuel, repairs, roads, ports, communications, institutions, funding, stability, and the dull but essential machinery that lets difficult work continue beyond a single expedition. We tend to imagine exploration as a dramatic moment, but much of it is repetition. Return trips, calibration, comparison, long-term monitoring, seasonal data, replacement parts that actually arrive, local partnerships that hold, safe movement of people and equipment, reliable support systems, the kind of practical scaffolding that never looks exciting in a trailer, but without which science quickly becomes a very expensive way to get wet and confused. The Congo has a way of exposing how much exploration relies on all the quiet structures around it. So as we settle into this subject, it helps to leave behind the expectation that there will be one grand reason. Not one answer, but many. Not one villain, unless you count current, depth, distance, weather, logistics, limited infrastructure, ecological complexity, variable access, and human history as a committee of villains, which would admittedly make for a very crowded poster. The real story is accumulation, one difficulty meeting another, one obstacle strengthening the next. A river that is not impossible in every place at every time, but difficult in enough ways, often enough, across enough dimensions, that full exploration becomes less like a single achievement and more like a horizon that keeps moving away as new questions appear. And this is where the map begins to mislead us. Because maps are useful, but they are also tidy by design. They flatten, they organise, they reassure, they take mud and flood and depth and current and danger and turn them into symbol, colour, line, label. They are marvellous tools and terrible substitutes for reality. The Congo on a map looks graspable. It begins to look like something you could trace with a fingertip and understand in an afternoon. Start here, curve there, pass this city, meet this tributary, continue west, empty into the Atlantic. Very nice, very clean. Possibly the sort of thing one could discuss over tea without ever having to swat an insect or wonder whether the water below the boat is calmly deep or violently deep, which are two very different moods entirely. Once you move from the paper version to the lived version, the neatness breaks apart. The line becomes a corridor of force, the banks become shifting environments, the surrounding forest stops being scenery and starts behaving like a system with its own rules. The distances begin to lengthen, the weather matters more, the human realities matter more. The water itself becomes less a surface and more a volume full of motion, with different layers, different speeds, and different hazards than the eye can see from above. That is the moment when the Congo stops being an object of casual geographic knowledge and starts becoming what it really is, which is a place whose reality is larger than its outline. And that difference, between the river you can point to and the river you can actually know, is where the next stretch of this journey begins. On a map, the Congo River can look almost polite. It begins as a line, gathers other lines, loops in a broad arc across Central Africa, crosses the equator twice, and eventually empties into the Atlantic. Atlases make this seem wonderfully manageable. The river is usually drawn in a single calm colour, with tributaries slipping neatly into it like well-behaved threads. You can trace it with one finger in a matter of seconds, and come away with the comforting impression that you have, in some small but respectable way, taken its measure. The trouble begins when that tidy blue line has to become an actual place again, because the real Congo is not merely a route across a page. It is roughly 4,700 kilometres long, drains a basin of about 3.4 million square kilometres, and sits inside one of the largest tropical forest systems on Earth. That already moves it out of the category of large river, and into the category of entire world in motion. Cartography, for all its brilliance, has a habit of making things look equally accessible. A capital city, a mountain, a marsh, a waterfall and a river crossing all sight together on the same page, reduced to symbols that seem to belong to one shared, understandable scale. The Congo resists that illusion almost immediately. The river's basin stretches across a vast portion of West Central Africa, and its reach extends through or along multiple countries, environments, and human realities that do not behave as though they were designed for a clean legend in the corner of an atlas. The map gives you outline, direction, and relation. It can show you where the water goes. What it cannot properly show is effort. It cannot show how long movement takes, how access changes with season and infrastructure, or how the difference between a navigable reach and a violent one can turn a single river into several different travel problems stitched together under one name. This is one of the first things that separates the Congo as diagram from the Congo as lived reality. On paper, a river appears continuous by default. There it is, one connected feature, whole from source to sea. In practice, continuity is not the same as ease. The Congo does function as a major inland waterway in large stretches, and it has served for centuries as a central route through the heart of Africa. But that broad truth can mislead if it is taken too simply. There are sections where the river opens into transport corridors and major human lifelines, and there are sections where rapids, cataracts, narrowing channels, depth changes, and fierce flow complicate movement so sharply that the sense of one smooth, unified route starts to collapse. A map can honestly tell you that the line connects. It cannot honestly promise that the journey behaves as one thing from beginning to end. Even its famous shape can trick the eye. The Congo's vast curve looks elegant from above, as though the river has made some thoughtful, measured decision about how to turn through the continent. In truth, that sweeping geometry contains different river personalities. There are broad middle reaches, major tributary systems, flood-prone lowlands, constricted sections, and downstream stretches where the water is forced through rougher gradients toward the Atlantic. Britannica notes that some parts of the Middle Congo widen to several miles, sometimes broken by strings of islands, while other sections narrow and deepen, with current accelerating as the river pushes through more confined terrain. To a cartographer, these are changes in shape. To anyone trying to move across, study, or map the river in detail, they are changes in behaviour, and behaviour is always more troublesome than shape. Shape can be drawn. Behaviour must be survived, measured, and interpreted. That is also why the simple phrase "the Congo River" can hide more than it reveals. It sounds singular, and geographically it is singular, but operationally it is a system of systems. It gathers the waters of immense tributaries, including the Ubangi, Sanga, Kasai, and others, and because the basin lies across both sides of the equator, rainfall patterns in different parts of the basin help sustain a comparatively regular overall flow. In map form, this can seem like a helpful fact, almost a reassurance. One imagines a river that is at least predictably full of itself. In reality, steadier, basin-wide flow does not make the river simpler. It makes it bigger, more persistent, and more influential. The same hydrological scale that makes the Congo look impressive from space also means that conditions are shaped by an enormous catchment rather than one local patch of weather. It is not easy to understand a river when the river is partly being decided hundreds of kilometres away. Seen from orbit, the basin can look almost serene. NASA has described the region as one of the cloudiest places on Earth, with low-altitude clouds often tracing the rainforest landscape. It is a beautiful image, and also a quietly misleading one. Clouds, dense forest, and broad watercourses have a way of making a place appear soft-edged and slow when viewed from above. Yet those same conditions can hinder direct observation on the ground, complicate remote sensing, and make the landscape feel less like a panorama and more like a series of partial views. The map offers a godlike angle, but reality is mostly experienced at human height, where jungle closes sightlines, riverbanks change character, channels divide, and certainty shrinks to whatever can actually be reached, tested, and safely revisited. The Congo is the sort of place where visible from space and understood in detail are not even remotely the same achievement. Then there is the matter of width, which maps often flatten into a simple visual impression of largeness. Some sections of the Congo are indeed broad, and in the middle course the river may spread across several channels separated by islands, with adjacent flood zones extending its watery influence even farther in the wet season. On the page, width looks almost forgiving. More room, one might assume, more space to pass. But broad tropical rivers are not wide in the same way a parking lot is wide. Width in a system like this can mean branching channels, submerged obstacles, variable depth, flood expansion beyond the main banks, and a great deal of uncertainty about where the river properly ends and the seasonally drowned world beside it begins. Britannica notes that it can be difficult even to distinguish some flooded zones from the swamps between rivers. A line on a map does not show that kind of blur very well. It prefers edges. The Congo often prefers not to provide them. One of the best examples of map neatness colliding with reality comes at Malebo Pool, the broad, lake-like expansion where Kinshasa and Brazzaville sit opposite one another. On the page, this looks almost like a pause in the river, a widening, a convenient node, a place where geography briefly becomes generous, and in practical terms it has great importance. Malebo Pool marks the point of departure for inland navigation, and its channels are navigable in ways that matter enormously for transport and settlement. But even here, the map's calmness can overstate the simplicity. This is not a decorative widening placed there for the convenience of cartographers. It is a strategic and hydrological turning point. Downstream of it, the Congo drops into the sequence of rapids and cataracts known as Livingston Falls, and that shift changes everything. A single blue shape on the map suddenly conceals one of the great interruptions in inland-to-ocean continuity anywhere in the river's course. Livingston Falls is a fine example of why maps deserve both admiration and suspicion. The relevant section is often just a segment of river between named places. A person glancing casually might see Kinshasa, see Matadi, notice the route, and imagine difficulty in the abstract, much as one imagines mountain roads, before actually driving on one in bad weather with poor brakes and very strong regrets. The reality is much less abstract. Britannica describes a series of 32 rapids and cataracts, extending about 220 miles, with a total drop of roughly 850 feet. That is not a minor inconvenience. That is a structural statement about what the river will and will not allow. The map shows connection. The falls enforce separation. They are part of the reason the lower and middle river do not combine into one easy transport story, and part of the reason the Congo has always been both corridor and obstacle at once. This is where the difference between geographic knowledge and operational knowledge becomes especially sharp. To know where the Congo is, a map is enough. To know what the Congo does, it is not. A map can tell you that the river reaches the ocean. It cannot tell you, at a glance, which stretches carry barges, which require portage or rail links around rapids, which change character with local water level, and which depths conceal flow patterns violent enough to make measurement itself a challenge. In the lower Congo, USGS studies have documented extreme depths greater than 200 meters in places and velocities exceeding 4 meters per second, with local bedrock strongly shaping the flow and with dramatic changes in underwater topography, even in reaches without obvious waterfalls. Once again, the page offers a line. The river offers a moving three-dimensional force field with opinions of its own. That hidden third dimension matters more than maps are willing to admit. We are used to thinking of rivers as surfaces because that is the part we see and the part maps most easily symbolize. But the Congo is not only broad and long, it is volumetric in a very serious way. Beneath the visible surface lie sharp bathymetric changes, underwater valleys, zones of shear, turbulence and depth contrasts that can influence ecology, navigation, and scientific access. The lower Congo in particular has drawn attention because it behaves in places less like the flat-bottomed river people casually imagine, and more like a deeply incised and highly energetic channel. In a calm room with a folded atlas, that is just a technical note. In a survey boat, that is the difference between assuming you're over a big river and discovering you're above an underwater landscape with the temperament of a very busy machine. The basin around the river adds another layer that maps cannot fully carry. The Congo Basin contains the second largest tropical rainforest in the world, and that forest is not mere decoration framing the water for scenic effect. It shapes access, climate, observation, biodiversity, settlement patterns, and the practical terms under which research and transport occur. WWF and Britannica both describe the basin as a vast ecological system, supporting enormous biological richness and millions of people who depend directly on its resources. That matters here because river exploration is never just about water. It is about the environment that hems the river in, feeds it, floods beside it, and limits movement away from it. On a map, forest often appears as colour fill. In reality, it is terrain, moisture, reduced visibility, biological density, and a constant reminder that knowing a river also requires knowing the world that leans over it. The human picture is similarly flattened by distance. A map can mark cities, ports, and settlements, but it cannot convey the degree to which the Congo functions as lifeline in some places and challenge in others. UNESCO describes it as the main commercial route through Central Africa for centuries, and that is no small claim. Yet the same river that binds places together can also isolate them when infrastructure is weak, when routes are interrupted, or when conditions shift. The river is not a blank frontier waiting for outsiders to notice it. It is already inhabited, used, understood in local and practical ways, and woven into regional life. What the map often hides is not absence, but density of dependence. The Congo is not difficult because it is empty. It is difficult because it is full of life, movement, need, memory, and constraints that do not simplify themselves for the convenience of distant observers. There is also a subtle trap in how educational maps teach us to think. They encourage a very democratic view of distance. 2 centimetres on the page and 2 more again. The ice slides along effortlessly. This makes Central Africa seem compressible in a way it absolutely is not. The Congo Basin spans enormous distances, and even where the river is navigable, travel is still travel. It takes fuel, time, maintenance, weather tolerance, local knowledge, and patience. National Geographic, in reporting from the river, put it bluntly in a more literary register. The pace out there is not governable. That observation fits the larger truth rather well. The map implies sequence. Real movement along the Congo involves delay, interruption, waiting, adaptation, and the quiet loss of any modern fantasy that every route should obey a schedule simply because a route exists. And perhaps that is the central mismatch. Maps are made to reduce friction. Rivers like the Congo generate it. A map wants legibility. The river often offers partial legibility at best. A map assumes stable categories: main course, tributary, port, floodplain, falls. Useful categories, all of them. But once you enter the actual system, each term thickens. Floodplain becomes a seasonal world. Port becomes an infrastructural question. Tributary becomes another major hydrological reality. Main course becomes a chain of different kinds of river joined under one name. Even bank begins to lose its certainty when floodwaters spread, and swamps merge visually and physically with the margins of the river itself. It is not that the map is wrong. It is that the map is innocent, and the Congo is not. So when people imagine the Congo as a place we should surely have fully explored by now, they're often thinking of the mapped river, the symbolic river, the river as shape. They're not thinking of the river as deep hydrodynamic system, as rainforest artery, as interrupted transport network, as flood-expanded landscape, as lived human corridor, or as a place where a broad blue line can hide rapids, canyons, turbulence, and enormous logistical strain. The paper version of the Congo is easy to admire because it sits still. The real one does not. It moves, swells, narrows, divides, drops, accelerates, and folds itself into a much larger world that no single glance can contain. And that is why the first honest step toward understanding this river is giving up the idea that seeing its outline means knowing what it is. Once that illusion is set aside, the jungle along its banks begins to look less like background and more like the next part of the problem. And that jungle, once the map has been folded away, stops behaving like background. The Congo Basin contains the second largest rainforest in the world, and over a large part of the basin, the equatorial climate is matched by dense evergreen forest, extending across the central depression, with only scattered clearings interrupting it. Britannica describes the forest as spreading continuously across a huge band of the basin, while the river and its tributaries cut through that mass of vegetation rather than standing apart from it in some comfortably visible corridor. That matters because the river is not presented to an explorer the way a mountain is, rising into view from afar, or the way a coastline is, opening itself in a long, obvious edge. The Congo often has to be approached from within the forest that already surrounds it, and the result is that the river can be very large while still feeling hidden, screened, and difficult to read until one is directly on top of it. This is one of the quiet tricks the river plays on the imagination. People often picture great rivers as open features in the landscape, wide enough to announce themselves long before you reach them. Some rivers do exactly that. They shine in the distance. They carve broad open valleys. They make a habit of introducing themselves. The Congo can be less generous. Britannica notes that, as the river courses through the forest, its banks may be fringed with papyrus, sedges, meadows, and strips of vegetation, while the high forest rises just behind. In practical terms, that means the river's edge is often not a clean line between water and dry land. It is a layered margin of grasses, channels, levees, islands, and forest curtains that break sight lines and reduce the sense of overview people assume they will have in a place this large. The river may be there in force, but seeing far along it or far across the surrounding country is another matter entirely. The air adds its own difficulty. NASA's Earth Observatory describes the Congo River basin as one of the cloudiest places on Earth, with low-altitude cumulus clouds forming over the dense rainforest and larger storm systems building along the intertropical convergence zone. That is a very elegant way of saying the sky is frequently busy. From the comfort of a satellite image, cloud patterns over the basin can look beautiful and almost orderly. For anyone trying to observe, travel, survey, or build a consistent picture of conditions on the ground, cloudiness is not decorative. It reduces visibility from above, complicates repeated remote observation, and adds another layer of uncertainty to a landscape already difficult to enter and harder still to summarize, even when the river itself appears relatively free of cloud in some aerial views. Because the cooler air above the water suppresses cloud formation, the forest around it often remains covered, and that contrast only sharpens how hemmed in the river really is by the atmosphere and terrain around it. Then there is the simpler issue of moisture, which has a talent for sounding harmless until it has soaked everything you own, fogged every lens, softened every path, and turned a routine morning into a negotiation with wet fabric and reduced visibility. Equatorial forest is not merely green. It is humid, rain-fed, and active at all hours in ways that matter to movement and observation. NASA has highlighted how moisture and solar heating combine over the Congo Basin to shape persistent cloud formation, while Britannica emphasizes the equatorial climate that supports the dense forest itself. That combination means explorers are not arriving in a clean, dry setting where distance can be judged easily and equipment behaves politely. They're entering a place where haze, cloud, damp surfaces and repeated rainfall are normal parts of the system. The river is hidden not because it is invisible, but because the environment around it constantly works against long, stable, uncomplicated seeing. Distance makes this even worse, because the Congo Basin is not only forested, it is vast. Britannica describes the basin as stretching more than 1,200 miles from north to south, and about the same distance from the Atlantic in the west to the Nile-Congo watershed in the east. Those numbers sound impressive in the calm, ceremonial way numbers often do. In practice, they mean that the river disappears into a very large world. It is one thing to say a river has a drainage basin covering roughly 3.46 million square kilometres. It is another to remember that every effort to understand that river has to contend with the size of the region, feeding it, changing it, obscuring it, and making it expensive to revisit. Exploration in a place like this is not only about one hard day on the water, it is about the long chain of days before and after, the supply lines, the repositioning, the return journeys, and the fact that a river stretched across so much territory can hide by simple arithmetic as effectively as by jungle. A map tends to make big places feel equally reachable, which is one of its most useful lies. The line is there, the basin is coloured, and the page holds everything still. On the ground, enormous distance behaves more like friction. National Geographic reported on 1,000-mile barge journeys on the Congo that can take months, which tells you something important about scale before any scientist has even unpacked a sonar unit. A route existing is not the same as rapid access. A waterway being important is not the same as a waterway being easy. The river may be central to transport in many regions, but that centrality often reflects the lack of simpler alternatives rather than the presence of convenience. Distance on the Congo is not just mileage. It becomes time, delay, exposure, fatigue, and the gradual realization that the river is not waiting in a neatly bounded research site. It is stretched across a region large enough to absorb plans and humble schedules. This is where the forest and the transport reality begin to reinforce each other. Britannica notes that while the Congo system facilitates navigation, it also hinders land transportation, and only a small number of bridges cross the Congo and its tributaries. The World Bank, looking more broadly at the Democratic Republic of the Congo, has noted that vast geography, extensive forest lands and crisscrossing rivers complicate infrastructure, while another World Bank study says travel in the DRC, especially along rivers, can take significantly longer than expected because of dilapidated infrastructure, rainy season washouts, river silting, and operational delays. This is not simply a complaint about inconvenience. It explains why the river can remain physically present and economically central, while still resisting the kind of dense, repeated, cross-checked access that full exploration requires. You can have a major river and still lack easy ways to get to the right stretch, at the right time, with the right equipment, and then get back again with useful data and functioning machinery. It also explains why the Congo can feel close and far at the same time. For millions of people in Central Africa, the river is not remote in the emotional or practical sense. It is part of life, trade, movement, food, work, and daily calculation. UNESCO describes the Congo as the main commercial route linking Central Africa and its primary forest to the Atlantic for centuries, and WWF notes that the wider Congo Basin supports more than 157 million people across 6 countries, with some 60 million relying directly on basin forests for food, medicine, materials, and shelter. So this is not some untouched blank where no one goes and nothing happens. The paradox is the opposite. The region is lived in, depended on, and used, while still remaining very hard to observe comprehensively from the outside. Human presence does not remove difficulty. In a place this large and dense, it often means the river is many things at once to many different people, none of which automatically add up to one complete and universal picture. Another part of the concealment is visual in the most ordinary sense. The Congo does not often permit the sort of commanding view that makes landscape legible quickly. In open country one can climb, stand and understand. In forested river systems one often drifts, rounds bends, enters side channels, meets islands, sees only the next wall of vegetation, and learns the place in fragments. Britannica's description of discontinuous grassy strips, papyrus stands, island vegetation, and forest rising behind levees helps explain why the river's borders can be so visually uncertain. They are alive, layered, and seasonally influenced. The eye likes clean margins. The Congo keeps offering transitions instead. That creates a specific kind of difficulty for exploration, because understanding is much easier when landscape separates itself into obvious units. Water here, land there, main channel in front, floodplain off to the side. The Congo often replies with something close to, approximately on a good day, for now. Seasonality complicates that further. Britannica's hydrology overview explains that the basin is so vast that no single meteorological circumstance controls the entire river system, and that rises and falls in water level reflect different rainfall patterns across the basin, including delays before tributary floods arrive from one region to another. That means the river is not only large and hidden, but also difficult to read from local appearances alone. Conditions in one reach may be shaped by rainfall far away and earlier in time, which is not the sort of arrangement that rewards casual confidence. What looks manageable in one week may alter in the next. What seems low may be on its way to rising. What appears stable may belong to a larger moving schedule no single observer at one bend can fully see. The river hides itself in distance, not just spatially, but hydrologically. Parts of its behaviour are written elsewhere in the basin, and arrive later like delayed news with very practical consequences. This is also why satellite images, however useful, never quite settle the matter. NASA can show the basin from above, reveal cloud structure, trace major waterways, and capture the relationship between forest, water, and atmosphere. Those views are genuinely valuable, but aerial visibility is not the same as operational clarity. A researcher or crew on the ground still has to work with landing points, fuel, river conditions, permits, local knowledge, equipment failure, illness risk, and the ordinary stubbornness of a place where nearly everything takes longer than neat planning suggests. The Royal Society has published work on building sustainable river science capacity in the Congo, which itself tells a story. You do not write about building lasting scientific capacity in easy places, because easy places tend to build it without so much ceremony. The very need to strengthen long-term river science infrastructure is evidence that this is not a setting where a single burst of attention produces enough understanding to satisfy the problem. The forest also changes sound, and while that may seem like a small detail, it matters to the human experience of navigation. Dense vegetation absorbs distance differently than open country does. Rivers in broad, open plains can announce themselves with exposed horizons, wind across water, visible storm lines, and long sight distances. In the Congo basin, forest edges, islands, and channel turns can compress the world. Boats emerge rather than approach grandly. Settlements appear suddenly. Weather arrives in partial glimpses. The river can be broad and still feel enclosed. This does not show up well on maps, because maps are excellent at area and mediocre at atmosphere. But atmosphere governs judgment, a place that limits line of sight and surrounds movement with vegetation changes how people estimate risk, plan routes, and interpret what lies ahead. Even a very large river can feel tactically local when the next bend is all you're allowed to know for certain. There is a temptation, especially from far away, to treat all this as romantic difficulty. Jungle, cloud, hidden water, long distances and slow boats do sound dramatic when arranged in the right order and read in a calm voice. The problem is that romance is often just logistics wearing flattering clothes. World Bank reporting on transport in the DRC makes plain that river movement can be slowed by washed-out roads feeding ports, silting that makes some river segments impassable in drier periods, and weak operational capacity. National Geographic's descriptions of journeys taking months add the human timescale to that reality. This is not mystery for mystery's sake. It is what happens when a huge river system moves through forested terrain, where infrastructure is uneven and maintenance is difficult. The river hides itself partly because approaching it, leaving it, and returning to it with consistency are all harder than outsiders tend to imagine. That helps explain why so many places in the world can be photographed, mapped, and discussed far more thoroughly than they are physically understood. The Congo is a textbook example. We can say where it is. We can identify major ports, major tributaries, major ecological zones, major transport links, and major hazards. We can even point to certain stretches and say with confidence that they matter enormously. But a river hidden by dense forest, cloud-prone skies, vast distances, limited overland crossings, and slow, fragile logistics does not yield a quick, total portrait. Britannica's reminder that only a small number of bridges cross the Congo and its tributaries may sound like a dry transport note, yet it captures something essential. In a place where crossings are few, access is channeled. Where access is channeled, knowledge becomes patchy. Where knowledge is patchy, the landscape keeps part of itself in reserve. Even the phrase, hidden in jungle, needs to be handled carefully, because the river is not literally missing. It is travelled, fished, lived with, and relied on. Hidden here means something more practical. It means difficult to see all at once, difficult to revisit evenly, difficult to observe from multiple angles with equal ease, difficult to convert from lived corridor into fully measured object. It means the forest narrows vision, the weather interferes, the margins blur, and the size of the basin prevents simple local understanding from becoming total understanding. It also means that what appears obvious from above can remain frustratingly partial below. A river can be central without being transparent. The Congo is one of the strongest examples of that on Earth, because its very importance sits inside environmental conditions that constantly reduce certainty and stretch every attempt at comprehensive access, and perhaps that is the most useful adjustment to make before going any farther. The Congo is not hiding in the sense that it wishes to be theatrical. It is hiding in the much more serious sense that rainforest, moisture, cloud, layered banks, seasonal shifts, immense scale and fragile infrastructure combine to keep the river partially out of view even when one is already near it. That is why so many accounts of the region are full of fragments, stretches, reaches, sections, approaches, corridors, crossings, and return trips. The place insists on pieces before it allows anything resembling a whole, which means that once the forest and the atmosphere have done their part, the next problem is waiting below the visible surface, where the Congo becomes harder still, because the water itself contains depths, velocities, and hidden structure that no curtain of jungle could possibly improve. Once the jungle and mist have done their part, the next difficulty begins in the place most people never see. The surface of a great river encourages a certain kind of false confidence. You look across it, see water moving from one bank to the other, and your mind quietly files it under one simple category: river. Broad, forceful, perhaps dangerous, but still one thing. The lower Congo has a habit of punishing that assumption. It is not just wide water moving downhill. It is a layered, fast, uneven column shaped by bedrock, abrupt underwater relief, violent local acceleration, and currents that do not behave like one smooth mass. In some stretches below Malebo Pool, researchers describe it as one of the deepest and most powerful river reaches on Earth, with whirlpools, high surface waves, and channel depths often greater than 100 meters on the way toward the Atlantic. That is the first adjustment worth making. Not every part of the Congo behaves like this. The full river system is enormous and varied, but the lower Congo, especially the reach between Malebo Pool and the Atlantic, is where the river stops being merely impressive and starts becoming hydraulically unreasonable. The US Geological Survey's work on the lower river notes that this stretch drops about 270 meters over roughly 498 kilometers and is riddled with rapids, cataracts, and deep pools. Even that description sounds more manageable than it really is, because the problem is not only the descent, it is how that descent is expressed. In the lower Congo, water does not simply move faster. It folds, separates, collides, and reorganizes itself over a submerged landscape that can be as dramatic as terrain on land, only hidden beneath a surface that reveals almost none of it. For a long time, much of this was inferred rather than directly measured. That by itself says something important. We're talking about a famous river, a major river, a river central to millions of lives and to African geography, and yet direct measurements of discharge below Malebo Pool were still noteworthy when US GES teams carried them out in 2008. Those measurements, made with acoustic Doppler current profilers, differential GPS, and echo sounders, found maximum depths in excess of 200 meters at maximum water velocities greater than 4 meters per second, with discharge near Luozi around 35,800 cubic meters per second during the study period. The same work emphasized that local bedrock exerts a major control on flow, even in reaches without obvious waterfalls and rapids, and that transects across the river reveal dramatic changes in bed topography. In calmer language, that means the lower Congo is not simply deep, it is structurally complicated in ways that can make the visible river a very poor guide to the river below. If you have never thought much about river bathymetry, that phrase may sound like something best left to hydrologists and very patient graduate students. But bathymetry is simply the shape of the bottom. And in the lower Congo, the bottom does not behave in the flat, gently sloping manner many people imagine when they hear the word riverbed. American Museum of Natural History field reporting on the Congo project describes echo sounder readings that found depths of around 220 meters in one stretch, along with underwater huge peaks and enormous troughs, as though one were boating over a mountain range. That is a striking image, but it is more than colourful reporting. It points to the underlying truth that the water column in the lower Congo is being organised by sudden relief beneath the surface. When the river passes over underwater cliffs, ridges, holes and canyon-like forms, it does not respond politely. It accelerates, spins, shears, and builds local circulation patterns that can be dangerous to craft, difficult to model, and surprisingly effective at isolating habitats. This is where the phrase "water beneath the water" begins to earn its keep. Most people, understandably, imagine a river as a moving skin above a somewhat simpler body. The top ripples, the rest follows. In the lower Congo, measurements show something much more complicated. At Bulu Reach, USGS researchers found that turbulent and secondary flow structures could span the full depth of the river, up to 165 meters, and that coherent bank-to-bank cross-channel flow structures were absent. Near bank regions of flow separation were isolated from one another, and from the opposite bank by high shear, high velocity zones, whose depth average flow could exceed 4 meters per second. That is a rather technical way of saying the river is not one simple corridor from shore to shore. It behaves more like several different hydraulic neighbourhoods pressed together, with rough boundaries made not of stone or shoreline, but of force. That force matters because rivers are often treated as if water were basically interchangeable within them. Dip your hand in here or there, and surely it is all part of the same thing. On a chemical level, fair enough. On a hydraulic level, not at all. In parts of the lower Congo, some parcels of water are moving much faster than others. Some are spinning upward. Some are pushed downward. Some are trapped in local circulation. Some sit in calmer pockets near banks or behind underwater features. Others are flung through narrow, high-energy paths with a kind of mechanical impatience. To a fish, a drifting branch, a net, a survey instrument or a small boat, those distinctions are not academic. They are the entire difference between remaining where you are, crossing safely, being swept away, or never reaching the other side at all. The surface may still appear to belong to one river, but the interior behaves like a structure with compartments and barriers of its own. This is also why depth by itself can be misleading. A deep lake is not the same problem as a deep river. In a lake, depth is mostly a matter of down. In the lower Congo, depth combines with current, slope, constriction, and underwater topography to produce energy. The deeper sections are not simply darker or harder to sample. They are often tied to abrupt hydraulic transitions, where water moving over submerged features generates whirlpools, jets, recirculation, and vertical displacement. A. MSH's Congo project described one Bulu canyon about 160 meters deep, where the water accelerates over an underwater cliff, generating whirlpools and jets strong enough to help explain why certain deep-dwelling fishes may be launched to the surface. That is not the sort of behaviour people expect from a river until they are forced to. It is one thing to imagine strong current. It is another to realise the current is being reworked in 3 dimensions by a hidden landscape. The river's surface offers clues, of course, but only partial ones. Whirlpools, standing waves, white water, and sudden roughness tell you that something energetic is happening below. What they do not tell you very well is the actual geometry of that energy. A whirlpool might suggest danger in the general sense, which is useful if you're trying not to capsize before lunch. It does not reveal where the deeper slot lies, how the current is splitting below the surface, or whether a calmer patch nearby is genuinely calmer or just the visible edge of a more violent circulation cell. This helps explain why even experienced local navigation knowledge and modern hydrological measurement are not interchangeable. Both are valuable. Neither automatically gives the whole picture. The river beneath the surface is too complex for quick visual reading alone, and the visible surface is too active to make instrument work easy. Researchers studying the lower Congo have had to use gear more commonly associated with marine work, precisely because the river exceeds the comfortable expectations of ordinary river science. AMNH's account of the Congo project notes that hydrologists used acoustic Doppler current profilers to measure speed and direction through a three-dimensional column of water, and that one scientist remarked the river was so deep they had to use instruments designed for the ocean. That is a memorable line, but it points to a serious limit. We often assume modern tools remove mystery by default. In places like the lower Congo, tools still help enormously, but the place determines the terms. Instruments must function in violent water. Survey craft must survive the reach. Measurements must be repeated enough to make sense of shifting conditions. Data then have to be interpreted in a system where bedrock, depth, and current are interacting in ways that are locally extreme and not visible to the naked eye. There is a tendency to think of exploration as a matter of reaching a place once and taking a reading, as though knowledge were a souvenir one brings back in a sample bag. But with a river like this, one measurement is often just the beginning of your confusion. The USGS work at Bulu and nearby reaches did not produce a neat, simplified portrait. It produced evidence of dramatic topographic change, high energy flow, bedrock control, and strong internal structure. That is useful precisely because it makes the river less abstract, but it also reveals how much had been hidden. The more closely the lower Congo is measured, the less it resembles a conventional river channel, and the more it begins to look like a narrow, deeply incised hydraulic world with its own local architecture. Knowledge expands, yes, but so does the list of questions that arise once the hidden structure becomes visible. Some of the most startling consequences of this hidden structure are biological. The lower Congo is not just hydraulically unusual, it is also a freshwater biodiversity hotspot, and scientists have tied part of that diversity to the river's extreme flow regime. AMNH reports more than 320 fish species in the lower Congo, around 90 of them endemic, and describes how regions of powerful white water and deep turbulent channels can act as barriers to fish movement over long periods, allowing populations to diverge. In this view, the river's internal hydraulics function like walls, only the walls are made of moving water. That is a useful reminder that what looks open to us may be closed to other creatures. A river can seem continuous on the map and still be fractured from within by currents strong enough to prevent routine crossing. The famous blind and depigmented cichlid, Lamprologus lethops, makes this point in a way that sounds almost invented, except that it is not. A genomic study published in Genome Biology and Evolution describes the species as endemic to the lower Congo and notes that available evidence suggests it inhabits deep, low-light habitats. The paper also notes the lower Congo's complex bathymetry, high-velocity in-stream flows, and canyons with depths greater than 220 meters recorded. Specimens recovered at the surface have shown signs consistent with catastrophic decompression after rapid ascent, including gas bubbles and damaged gas bladders. In other words, the river's hidden depth is not just an engineering problem. It may be shaping animals that live in places we scarcely sample directly, and occasionally throwing them upward in damaged condition as accidental evidence of a world below the visible current. There is something almost unfair about that. The river withholds direct access, then sends up clues that raise even more questions. A blind fish, a deep canyon, a surface pattern hinting at a submerged cliff, a current profile showing zones of separation and shear. Each finding makes the lower Congo more legible and more unsettling at the same time, because the implication is not only that the river is deep, but that depth is ecologically occupied, hydraulically active, and unevenly connected to the surface. A truly explored river would be one where the bottom can be mapped, the flow understood across conditions, the habitat sampled routinely, and the interactions among all three described with confidence. The lower Congo remains some distance from that standard, not because no one has looked, but because looking here is unusually difficult and the underwater world is unusually structured. It also helps to remember that the hidden water does not stop where the river meets the sea. Offshore, the Congo connects to the submarine Congo Canyon, and recent work in nature communications has shown just how efficiently that connection can carry energy and sediment into the deep ocean. Researchers documented turbidity currents originating from the Congo River mouth, with one flow travelling more than 1,130 kilometres and accelerating from 5.2 to 8.0 metres per second. That is not inside the freshwater river itself, of course, but it tells you something important about the system as a whole. The Congo is not merely a surface stream ending at a coastline. It feeds a source-to-sink system in which gravity, sediment and flow continue to organise powerful movement far beyond what a casual river image suggests. The hidden structure of the Congo, in other words, has offshore consequences measured on astonishing scales. And because these processes are so energetic, measuring them is not just scientifically hard. It can be physically punishing and expensive. Direct monitoring of powerful turbidity currents in deep-sea canyons was long thought impractical, precisely because such flows can damage or destroy instruments, and the same general principle applies in miniature within violent river reaches. Strong flow is not merely an inconvenience for equipment, it affects where you can deploy, how long you can hold position, what sort of vessel you need, how data quality degrades in rough conditions, and whether the river will let you revisit the exact spot under comparable circumstances. The lower Congo is not hostile every second everywhere, but it is hostile often enough, and in sufficiently complicated ways, that building a dense, repeated observational record becomes a very serious undertaking. This also explains why surface familiarity can coexist with underwater ignorance. People can live beside a river, cross it, fish it, trade along it, and still not know its deepest flow architecture in a technical sense. Those are different kinds of knowledge, and a place this forceful can keep them separate. The river that carries barges or ferries in one reach can still contain nearby zones where the current is too strong for easy crossing. The river that looks broad enough to invite movement can still hold hidden slots, cliffs, and jets below. The river that appears calm from a bank can, a short distance away, be moving as though it had remembered it was in a hurry. The lower Congo is full of these double truths, and they are part of why exploration here is never a simple matter of being present. Presence is not the same as penetration. Seeing the surface is not the same as understanding the water column. In a sense, the lower Congo behaves like a river that has swallowed part of the logic of the sea. There is vertical structure, localized low-light habitat, instruments borrowed from oceanography, and a bottom relief dramatic enough to create deep channel behaviour people do not usually associate with inland water. Yet it remains unmistakably a river, carrying fresh water, species, sediment, and human traffic through a continental landscape. That combination is what makes it so difficult. If it were only a deep river, one set of methods might suffice. If it were only a rapid river, another set. If it were only a biologically rich river, another. Here, those problems overlap. Depth intensifies current. Current intensifies isolation. Isolation shapes biodiversity. Biodiversity reveals hidden hydraulic compartments. The system keeps tying one difficulty to the next. And so the phrase, water beneath the water, is not just a nice turn of language. It is the practical heart of the problem. The visible river is only the beginning. Below it lies a fast, contoured, partially hidden machine, driven by descent and shaped by bedrock, with zones of darkness, turbulence, upward jets, and separation strong enough to matter to fish, boats, instruments, and anyone foolish enough to assume a river should behave as one consistent thing from bank to bank. The lower Congo reminds us that a surface can be honest and still incomplete. Yes, there is the river. No, that is not all there is. And once that becomes clear, another difficulty presents itself almost immediately, because if the water itself is already this hard to understand, then the question becomes how boats, sonar, and all the clever modern tools we trust are supposed to operate reliably in a place that seems designed to make every measurement hard-won. Modern tools do help. They help a great deal. But the Congo has a way of forcing every clever instrument to admit its limits before the work is done. That is the first thing worth saying plainly. Boats can move on the river, sonar can measure depth, acoustic profilers can estimate velocity, satellites can watch water level and channel change, and digital charts can make navigation safer. None of that is imaginary. The difficulty is that each of those tools arrives with assumptions about stability, access, power, calibration, repeatability, and signal quality, and the Congo keeps interfering with those assumptions from several directions at once. In the lower river, direct USGS measurements found depths greater than 200 metres and maximum velocities above 4 metres per second, with strong bedrock control on flow and dramatic changes in bed topography across transects. That is not a polite environment for routine surveying. It is the kind of place where measuring the river is itself an expedition rather than a clerical task. A boat, after all, is only as useful as the water will allow it to be. People often talk as though a vessel is the solution to a river, but on a river like the Congo, a vessel is really just the beginning of the negotiation. The Canadian ADCP field standard notes that in fast and turbulent flow, heave, pitch, and roll can entrain air beneath transducers, block acoustic signals, and introduce uncertainty into measurements. It also notes that invalid bottom track data become more common where turbulence, sediment transport, and rough beds are involved, and that in such conditions the safest, most stable deployment methods are preferred, often using larger manned boats or specially designed tethered craft. That is a very measured way of saying that the boat has to survive the river before the science even starts. And even when it does survive, its motion can become part of the measurement problem. This is one reason the phrase "we'll just scan it" sounds so confident from a distance and so fragile on the water. Acoustic Doppler current profilers, or ADCPs, are remarkable instruments, but they do not see every part of the river equally well. USGS guidance explains that an ADCP cannot measure velocity right at the water surface because of instrument draft and blanking distance, and it cannot measure all the way to the bed because of side lobe interference. In other words, the top and bottom portions of the water column are partly missing from the direct record and have to be estimated from the measured middle, on a calm, well-behaved river that can be managed with careful methods. In a river as deep, fast, and hydraulically uneven as the lower Congo, those invisible zones become more than a technical footnote. They become exactly the places where one would very much like the river to stop being difficult, and it refuses. There is a slightly comical quality to this if you imagine the river overhearing our plans. Humans arrive with precision gear, software, and respectable confidence. The river replies, "Very good. You may now estimate the parts you cannot directly measure." That is not because the technology is weak. It is because acoustic measurement has physical constraints. USGS notes that the amount of water column lost to side lobe interference depends on geometry and can amount to roughly 6% to 13% of the depth, while the upper unmeasured zone depends on draft, blanking distance, and flow disturbance around the instrument mount. The deeper and more energetic the river, the more those missing sections matter. 100 small unknowns in a shallow stream are one thing. A few unknown bands inside a river system already known for violent internal structure are another. Then there is sediment, which behaves like a saboteur with excellent timing. Acoustic instruments need suspended material in the water to reflect sound back to the sensors. Pure water is too acoustically transparent, so a little suspended matter is useful. too much, however, becomes a problem. USGS guidance states that high sediment loads can produce either excessive backscatter near the bed, making it hard to distinguish the streambed from suspended sediment, or excessive attenuation, where the acoustic signal weakens before it can travel through the water column and return. The same guidance adds that lower frequency instruments can penetrate high sediment concentrations better than higher frequency instruments. But lower frequencies also require larger depth cells and longer blanking distances. So even here there is no perfect tool, only a trade-off. More penetration usually means less detail. More detail usually comes with shorter reach or greater vulnerability to difficult water. That trade-off becomes especially uncomfortable in the Congo because detail is not a luxury there. It is the whole point. A river with ordinary bottom contours might tolerate broader, coarser measurement without hiding too much from you. The lower Congo is not ordinary in that sense. USGS fieldwork and subsequent analyses show abrupt bed topography, extreme depth, high velocities, and strong local bedrock control. When the underwater landscape includes sudden troughs, submerged ridges, deep slots, and high shear zones, the choice between seeing deeply and seeing finely is not a minor engineering preference, it is an interpretive problem. You want enough acoustic reach to deal with very deep water, but you also want enough spatial resolution to understand the complex structure that makes the water dangerous and biologically important in the first place. The river, quite unhelpfully, demands both. Even bottom tracking, which sounds reassuringly solid, can become unreliable in active river conditions. USGS explains that bottom tracking assumes the streambed is stationary, but where sediment is moving along or near the bed, the returning acoustic signal can be biased by that moving material, creating what hydrologists call a moving bed problem. In such cases, measured boat motion may be biased and water velocities and discharge can be underestimated unless corrected with other methods such as GPS. Again, this is not an exotic flaw unique to the Congo. It is a known limitation of acoustic river measurement. The trouble is that the Congo offers exactly the sort of fast, sediment-laden, difficult conditions where that limitation matters. A river with intense flow and active nearbed sediment transport is precisely where you would prefer the bottom to behave itself, and precisely where it may not. There is another nuisance, and it is one of those details that sounds trivial until it ruins your dataset. Boats move, they yaw, bounce, lean, and twist. In ordinary travel, this is annoying. During hydroacoustic measurement, it can become destructive to data quality. The Canadian Field Standard notes that waves and turbulent surface conditions can produce air entrainment beneath the transducers, and that this can block acoustic signals and return invalid data. The same motion also changes instrument draft, which increases uncertainty in the measurement. It is a useful reminder that instruments do not float in abstract space. They are bolted to real boats in real water, and the quality of the result depends partly on whether the river grants the vessel a stable enough platform to listen properly. The Congo often prefers not to grant favours of that sort. And this brings us to sonar more generally, because sonar sounds modern enough that people sometimes treat it as a magic word. But sonar is still sound in water, and sound in water is affected by conditions. High turbulence, air bubbles, suspended sediment, abrupt relief, rapid velocity changes, and unstable platforms all complicate the clean return of acoustic signals. USGS guidance notes the effects of ringing, flow disturbance, side lobe interference, and noisy profiles. It even notes that some profile estimation methods produced unrealistic results because of noisiness in ADCP data, especially toward the upper part of the profile, which forced the adoption of more robust extrapolation approaches. That is about as far from effortless technological mastery as you can get, while still using very good instruments. The machine is sophisticated. The river is simply more difficult than the machine would prefer. It also matters that the Congo does not offer one stable, universally convenient survey environment. The IHO Technical Visit Report on the Democratic Republic of the Congo emphasizes that river navigation in the basin involves more than 25,000 kilometers of waterways and more than 15,000 vessels, and that safer, faster navigation depends on better hydrographic knowledge and digital cartography. That same report points to material constraints specific to the navigation area, including weak or absent internet connection during navigation and limited onboard energy, which can prevent laptops from being integrated on board. This is the part of modern technology people forget. Devices do not arrive alone. They arrive with batteries, power demand, software, spare parts, update needs, connectivity assumptions, and training requirements. A river system may be large enough to justify advanced digital navigation and still operate in conditions where the most practical platform is not a sleek onboard survey computer, but an offline smartphone app prepared before departure. That practical constraint says a great deal. When experts designing inland electronic navigation for the Congo Basin explicitly emphasize downloadable maps, offline use, and smartphone-based tools, they are not being quaint. They are responding to the reality that modern navigation cannot assume constant connectivity or abundant onboard power. The IHO report goes further and notes that local marking practices may be non-standardized, meaning applications need to integrate symbols and objects specific to the navigation zone. It also notes the importance of allowing navigators to report shifting sandbanks, changes to aids to navigation, and other evolving hazards. In other words, even digital modernity has to become humble on the Congo. It has to be portable, offline, locally adaptable, and prepared for the river to change its mind while you're still using yesterday's chart. That last point is worth lingering on, because a river is not a road, and a chart is not forever. The EUMETSAT and SEACOS work on inland navigation support in the Congo Basin describes the use of bathymetric, hydrographic, hydrological and satellite data to develop electronic navigation charts, along with radar-based monitoring of river width, sandbanks and papyrus islands, plus water level monitoring using altimetry. The very fact that these services are needed tells you something important. If a river's channels, obstacles and margins were stable enough to be treated as settled, there would be less urgency around repeated observation and dynamic geoservices. But the Congo's navigable channels are shaped by moving water, changing shoals, vegetation rafts and fluctuating levels, so even a modern chart is not a final portrait. It is more like a careful update in an argument the river intends to continue. This is also where old charts begin to haunt the story. A 2022 preprint on updating century-old Congo River navigation maps notes that river transport in the basin relies on more than 17,000 kilometers of navigable channels, but that the sector has declined in part because of civil unrest, aging equipment, lack of infrastructure maintenance, and poor support and operation of public waterway agencies. It adds that the navigation maps used for the 1,700-kilometre stretch between Kinshasa and Kisangani originate from the early 1900s and have not been updated since colonial times. It is hard to overstate what that implies. We're not simply dealing with a river that is physically difficult. We're dealing with a river where the informational scaffolding for safe, repeatable, modern navigation has long been incomplete or outdated in major stretches. That makes every boat more cautious, every cargo movement slower, and every scientific campaign more dependent on a patchwork of local skill, partial data, and practical improvisation. The infrastructure picture around the river makes the same point in broader terms. World Bank documentation on the DRC describes the country as having some of the most challenging transport infrastructure in Africa because of geography, low population density, extensive forests, crisscrossing rivers, lack of investment and conflict. It notes that water transport has traditionally been the dominant means of movement across roughly 2/3 of the country, but with insufficient port infrastructure. That matters because boats and sensors do not begin and end their work in theory. They need ports, repairs, fuel, trained staff, security, supply chains, and routes that connect river transport to the rest of the world. A place can have thousands of kilometres of navigable waterways and still make every serious survey campaign slower, more expensive, and more fragile than outsiders expect. It is tempting at this point to imagine that satellites will simply bypass all this trouble. They certainly help. They can monitor width, water level, surface changes, and broader hydrological patterns, and they are already part of navigation support systems in the basin. But satellites do not replace bathymetric surveys, near-bed velocity measurements, or the physical act of checking what the water is doing where vessels actually travel. EUMETSAT's Congo navigation support materials make this very plain by combining radar, optical imagery, altimetry, hydrographic data, and electronic charts rather than pretending any one source is sufficient. The system needs multiple data streams because the river has multiple ways of being troublesome. A satellite can show the channel pattern. It cannot on its own tell a captain or a field team everything about near-surface turbulence, moving bed conditions, local buoyage loss, or whether the survey boat will keep a stable enough posture for clean acoustic returns at the exact reach being measured. And then there is the simple fact that some of the Congo's most important hydraulic features are underwater and violently local. A satellite may see the broad river and even some surface signatures. It does not directly hand you the hidden cliff, the deep slot, the separation zone, or the acoustic blind spot near the bed. USGS direct measurements in the lower Congo were notable, precisely because they provided first direct discharge measurements below Malibo Pool and showed maximum depths over 200 metres, velocities over 4 metres per second, and strong bedrock control in reaches that do not necessarily advertise their complexity from above. That is why river science here still needs boats, profilers, echo sounders, GPS, and crews willing to work in difficult water. The hidden structure of the river cannot be fully inferred from the sky. Somebody still has to go out there and let the water make the job difficult in person. What all this means, in the gentlest possible terms, is that modern tools are not failing because they are bad. They are struggling because the Congo keeps stacking problems on top of one another. Deep water demands one kind of instrument choice. Fast water punishes stability. Turbulence introduces bubbles and invalid data. Sediment can either help or hinder acoustic return depending on how much of it there is and where it sits. Bottom tracking can be biased when the bed is not behaving like a fixed reference. Charts need constant updating because channels, hazards, and navigation aids evolve. Connectivity and power constraints limit what can be done on board. Infrastructure deficits make it harder to repeat surveys, maintain vessels, and circulate updated information. No single obstacle is unbeatable. The trouble is that they arrive together, and they rarely arrive on schedule. So the picture that emerges is not one of technological helplessness, but of forced humility. The Congo can be mapped more accurately now than before. It can be monitored better than before. It can be navigated more safely where hydrography, local skill, and updated digital tools are improving. But it still resists the fantasy that boats, sonar, and modern systems automatically dissolve difficulty. They do not. They narrow the uncertainty, sometimes beautifully, yet they do so in a place where uncertainty keeps regenerating through flow, shifting channels, old infrastructure, unstable access, and the sheer stubborn force of the water itself. Which is why even after the boat has crossed, the signal has returned, and the chart has been updated, the river has another way of complicating matters. Because the Congo is never only water. Along the banks, the floodplain and forest are already waiting to close back in. There is a point somewhere along a riverbank in a place like this where the word bank starts to feel a little dishonest. It suggests a clean edge, a tidy border, a place where water ends and land begins with the sort of firm certainty mapmakers enjoy. Along much of the Congo system, the reality is messier, wetter, and far more alive than that. Britannica notes that as the Congo and its tributaries pass through the forest, they are often bordered by discontinuous grassy strips, papyrus, sedges and vegetation occupying abandoned channels, fringing the banks and filling depressions behind curtains of forest or across islands fertilized by floods. In other words, the margin of the river is not one line. It is a zone, sometimes a broad one made of water, reeds, mud, roots, floating growth and forest that leans close enough to turn the edge itself into a living wall. That living wall matters because it changes the basic terms of exploration. A rocky shore may stop you, a cliff may force a detour, but a floodplain forest, a papyrus-fringed channel, or a swampy bank does something more irritating. It pretends from a distance to be passable. Green is often misread as open if the eye is tired or the observer is optimistic. Yet the Congo's river margins are frequently built from vegetation growing in waterlogged ground, from depressions holding floodwater, from islands with inner wetlands hidden behind forest cover, and from river-adjacent habitats whose solidity is conditional at best. A boot sinks where the eye expected firmness. A channel appears where undergrowth looked continuous. A patch of land that seemed merely muddy turns out to be functionally aquatic. The bank, in short, keeps changing categories just when you would prefer it to choose one. This is one of the simplest reasons the Congo remains hard to know fully. Reaching the water is not the same as moving along it, and moving along it is not the same as stepping away from it to survey what surrounds it. The floodplain and forest together make lateral access difficult. You can be right beside the river and still find that the surrounding terrain refuses to behave like normal ground. Recent work on the Cuvette Centrale peatland complex describes a vast region of wetlands in the centre of the Congo basin, shared by the Republic of the Congo and the Democratic Republic of the Congo, and identifies it as the largest tropical peatland complex in the world. That alone is enough to complicate any easy picture of banks. The river does not merely flow past upland forest. In major parts of the basin, it interacts with sprawling wetland and swamp systems that are waterlogged, hydrologically variable, and in many areas still insufficiently characterized. What makes this especially troublesome is that flooding here is not just an occasional dramatic event where the river briefly misbehaves and then returns to normal. Flooding is part of the normal function of the wider system. Search summaries of Congo basin hydrology note that wetlands in the basin play a significant role in dampening flood waves by storing water during flood peaks and later releasing it. Other recent work estimates that the basin holds roughly 476 to 502 cubic kilometres of total drainable water storage, a quantity close to the volume of Lake Erie. Those are not side notes. They mean the land along and around the river is participating in the river's behaviour. Water does not remain politely confined to the main channel. It spreads, pauses, seeps, pools, and lingers. The bank therefore behaves less like a boundary and more like a negotiation between river, wetland, rainfall, shallow topography and vegetation. A place like that is difficult not only because it is wet, but because it stores wetness in ways that flatten time. In a simpler landscape, the difference between dry season and wet season might be noticeable but intelligible. Here, the legacy of earlier water can remain spread across forests and swamps long after rain has moved elsewhere. The Peatland Review for the Cuvette Centrale notes that some riverine wetlands next to the Congo main stem and along certain left bank tributaries in the DRC can experience inundations of up to 1 to 1.5 metres in the main wet season, while other interfluvial basins have shallower flood depths. It also emphasises that hydrology varies across the region and that understanding the relationship between river networks and adjacent wetlands remains a major research need. That is the hydrological version of a place refusing to sit still for a portrait. One bank is not the next bank. One flooded forest does not tell you the whole basin. A route that works in one season or in one type of wetland may become foolish elsewhere. Vegetation amplifies every one of those uncertainties. The grasses, papyrus, sedges, swamp forests, palms and wooded strips do not merely decorate wet ground. They conceal its shape, slow movement across it, and make judgment harder. Britannica's description of papyrus and cypressaceae fringing banks and occupying abandoned channels, together with meadows in island depressions behind curtains of forest, captures the awkwardness rather well. Even where the river seems to offer open space, the margins may be threaded with old channels, drowned hollows, and vegetated pockets of water that turn a short overland distance into a very long inconvenience. A person trying to study water quality, launch equipment, or simply find a reliable landing place is not dealing with one edge. They are dealing with a layered threshold that behaves a little like a trap for simple assumptions, and if the physical ground is uncertain, the ecological value of that uncertainty is very high. Wetlands and floodplain forests in the basin do important work that a dry, orderly landscape would not. The World Bank's Congo Basin Forest Ecosystem Synthesis emphasises that these forests support millions of livelihoods, regulate regional rainfall, maintain soil stability, reduce erosion, and serve as the world's largest net carbon sink. The peatland literature adds that these waterlogged ecosystems regulate regional hydrology and provide habitat for unique and endangered flora and fauna, while the Cuvette Centrale peatlands alone contain globally significant carbon stores. That means the living wall along the river is not an obstacle in the trivial sense, as though it were merely in the way of our tidy ambitions. It is an active part of the basin's climate function, water storage, and ecological structure. The very features that frustrate exploration are the ones helping keep the basin ecologically consequential. There is a tendency, especially in stories about difficult rivers, to treat floodplain vegetation as if it were passive scenery. But vegetation in the Congo margin is part of the hydraulic machinery. Dense plants slow water locally, trap sediment, create refuges and barriers, and help determine where the edge of the river appears to be from one week to the next. Search summaries on Congo floodplains and wetlands note that wet areas delay water transfer and modify sediment transport through both sedimentation and erosion. That means the bank is not simply shaped by the river. It is also shaping the river back, at least in its immediate margins and floodplain exchanges. A wall of reeds, a drowned forest, or a silted side channel can alter how water spreads and retreats. To an explorer or surveyor this becomes tiresome. To the basin itself, it is one of the ways order is maintained without ever becoming simplicity. The floodplain forests also have a gift for making scale slippery. A few metres inland can become functionally inaccessible, not because the distance is great, but because each step has to be negotiated with mud, roots, shallow water, unstable vegetation mats, insects, and limited visibility. Then those few metres become 50. 50 becomes a morning. A morning becomes an aborted approach to somewhere that looked perfectly reachable from the boat. This is where the grand reputation of the Congo sometimes rests on very mundane truths. It is not always the spectacular rapid or the canyon-like depth that stops you. Sometimes it is the fact that the bank is not a bank in any civilized sense. It is a wet vegetal argument in which every route votes against progress. That may not sound dramatic enough for a poster. It is, however, exactly the sort of thing that makes repeated methodical exploration much harder than distant observers expect. Another difficulty is that the floodplain does not merely store water, it stores partial knowledge. The Peatland Review notes plainly that there remain many unknowns about the biodiversity, vegetation communities, and hydrological variation of the Cuvette Centrale, and that data acquisition is challenging because of the vast extent and relative inaccessibility of these ecosystems. It even remarks that, beyond carbon storage, very little is known about some ecological roles of these peatlands. That is a striking admission. In one of the largest wetland forest systems on Earth, entire categories of understanding remain incomplete, not because nobody cares, but because the combination of size, waterlogging, vegetation and access makes ordinary field science slow and expensive. The bank does not just block your feet, it blocks the accumulation of consistent, dense knowledge over time. This is why floodplain forests are so often the hidden middle term in stories about the Congo. People speak of the river and the jungle as if those were separate actors. In reality, the important action often happens in the in-between world. The flooded margin, the swamp forest, the abandoned channel, the sedge-fringed depression, the peatland basin, the seasonally inundated strip where the river is neither fully contained nor fully escaped. Hydrological work on the basin has increasingly emphasized these wetlands, peatlands and floodplains precisely because they are central to how water moves and is stored across the system. When wetlands absorb peak water and release it later, they change flood timing. When vegetation and shallow topography hold water in place, they reshape the relationship between main channel and adjacent land. The result is a river whose banks cannot be understood as mere edges because they are actively participating in the movement and delay of water. There is also a quiet cruelty in how this living wall treats observation. Scientists increasingly use radar in the Congo basin because, unlike some optical methods, radar can detect patterns of flooding through forest canopy. The Peatland Review explicitly notes that long wavelength radar is particularly useful for mapping inundation because the signal can pass through the forest canopy and detect ground-level flooding. That is a remarkable capability, but it also tells you just how visually deceptive the bank can be. If one needs specialized radar to understand where water sits beneath the trees, then ordinary human seeing is already at a disadvantage. The flooded forest may look solid from one angle and aquatic from another. The river may appear bounded while the adjacent wetland remains full. The living wall along the bank can therefore hide water in place, not only by physical obstruction, but by disguising what is submerged beneath green cover. This has consequences for people living in the basin, as well as for outsiders trying to study it. WWF notes that the Congo Basin supports many ethnic groups and communities who rely directly on forests for food, medicine, materials, and shelter, and UNESCO has described the Congo as the main commercial route through Central Africa for centuries. Such dependence means the bank is never only a scientific problem. It is also a working landscape, a source of fish, plant materials, travel routes and daily risk. Flooded margins may nourish fisheries, sustain forest resources, and create wildlife habitat while also making movement uncertain or seasonal. That dual nature matters. The living wall is not empty resistance. It is full of usefulness and difficulty at once, which is part of why any simple conquest narrative feels so clumsy here. You're not looking at useless obstruction. You are looking at one of the ways the basin sustains life, even while it frustrates neat access. One can also see why engineering alone does not dissolve the problem. You can chart a channel, you can land a boat, you can build up some local access. Yet the floodplain forest remains seasonally dynamic, biologically dense, and hydrologically influential. The World Bank's wider work on the Congo Basin stresses the forest's roles in rainfall regulation, erosion reduction, and livelihood support, while hydrological studies emphasize the storage and delayed release of floodwaters in wetlands. Those are basin-scale services produced by conditions that are, at human scale, awkward and disorderly. Drain too much, clear too much, or force too much straightness into such a system, and you would not simply simplify exploration. You would begin to damage the very processes that keep the basin functioning as a climate, water and biodiversity engine. The bank remains difficult, partly because the bank is doing important work. It is worth noticing how often the language of the science keeps circling back to uncertainty. Unknown hydrological heterogeneity, incomplete biodiversity surveys, relative inaccessibility, need for more in situ water level monitoring, need to understand the relationship between river networks and adjacent wetlands, need for better flood mapping across peatlands. These are not small loose ends. They are signs that even now, in the age of satellite observation and digital modelling, the Congo's banks are still withholding detail, not theatrically, not maliciously, simply by being wet, vast, vegetated and hard to enter often enough. The living wall does not need to fight explorers in any dramatic sense. It only needs to make each return trip slow, each transect costly, and each simple generalization slightly premature. That has been enough, and perhaps that is the best way to picture it now. Not as a single bank, but as a breathing margin, a place where water is stored, delayed, mapped, and redistributed. A place where papyrus and sedges claim abandoned channels, where forest hides drowned depressions, where peatlands hold ancient carbon under saturated ground, and where the line between river and land becomes so wide and alive that the very idea of an edge starts to fail. A place useful to people, essential to climate, rich in habitat, and persistently awkward for anyone hoping the Congo would reveal itself cleanly once they reach the shore. By the time you have understood that much, the riverbank has already done its job. It has stopped being scenery and become one more reason the Congo cannot be fully entered on our terms. And once a river margin becomes that alive, it is only natural to suspect that the life within it has learned a few ways of staying out of sight as well. A river like the Congo does not merely hide its channels and depths, it also hides its inhabitants, and it does so in several different ways at once. Some animals vanish because the forest is dense, the water is dark, and the margins are flooded for long periods. Others remain hard to study because their habitats are remote, patchy, or dangerous to sample. Others still are simply small, strange, and living in places where not many people have looked closely enough for long enough. That is part of what makes the Congo so different from the wildlife scenes people often carry around in their heads. This is not a place where every important creature steps neatly into a clearing at golden hour and waits for a camera crew to get the framing right. Much of the life here is hidden by vegetation, hidden by depth, hidden by distance, or hidden by the fact that even now the basin is still yielding new species at a surprising pace. WWF reported in late 2024 that 742 new species were identified in the Congo Basin over the previous decade, including fish, amphibians, reptiles, birds, mammals, plants, and invertebrates. That is a remarkable number, and it tells you something basic before you even start naming animals. The basin is not finished giving up its inventory. That matters because people often imagine exploration and animal knowledge as though the two were settled by the same moment. You go somewhere, you see what lives there, you make a list, and eventually the list becomes complete. The Congo has never behaved that politely. WWF's Congo Basin Overview describes the region as home to endangered wildlife, including forest elephants, chimpanzees, bonobos, and lowland and mountain gorillas, while also emphasizing that the basin remains one of the most biologically rich places on Earth. When a landscape of that scale and complexity is still producing hundreds of newly identified species within a 10-year span, the lesson is not merely that it is full of life, it is that its life is unevenly visible. Some creatures are large and famous, some are local and poorly known, some are represented in science by only a handful of specimens, a few camera trap images, or occasional field observations separated by years and difficult travel. The basin's animals are not hidden in one simple sense. They are hidden by abundance, by habitat, by inaccessibility, and by the fact that our sampling has never been as complete as our confidence sometimes sounds. Consider the okapi, perhaps the most polite-looking reminder that a forest can hide something enormous. The okapi is endemic to the Democratic Republic of the Congo, and UNESCO's Okapi Wildlife Reserve page notes that the reserve contains about 5,000 of the estimated 30,000 okapi surviving in the wild. This is not a tiny, mythical forest phantom in the way people sometimes speak of elusive animals. It is a large mammal, a relative of the giraffe, wearing stripes like an animal designed by committee. And yet it lives in a landscape where being large does not guarantee being easily seen. Dense rainforest, patchy distribution, and the simple difficulty of sustained surveying mean that even well-known flagship species in the Congo remain more concealed than outsiders expect. The okapi is not hard to imagine because it is small. It is hard to know well because the forest is doing what forest does best, which is turning even a big animal into a local fact rather than a constant spectacle. The same is true, in a different way, for bonobos. WWF notes that wild bonobos are found only in forests south of the Congo River in the DRC, and that much remains unknown about them, including the full extent of their range, because surveys have been hampered by remote habitat, patchy distribution, and years of civil unrest. There is something quietly striking about that. We are speaking of one of our closest living relatives, not some microscopic invertebrate in an inaccessible swamp, and still the basin keeps parts of its story incomplete. The river itself is part of that story too. Bonobos are restricted to forests south of the Congo River, which means the river is not only a setting for wildlife, but a boundary shaping where some of the basin's most famous animals live. Even here, the Congo is not simply home to creatures, it arranges them, it separates them, it sets terms on where they can be found and how easily they can be studied. Forest elephants offer another version of the same lesson. WWF describes Salonga National Park as a stronghold containing one of the last viable populations of forest elephants remaining in the DRC, and elsewhere notes that forest elephants are major seed dispersers in Congo Basin forests, with roughly 1/3 of hardwood tree species in the basin known to be eaten and dispersed by them. That is not just a nice ecological detail, it means that some of the largest animals in the basin are helping shape the forest that then helps hide so much of the rest of the wildlife. Without forest elephants, parts of the forest would not regenerate in the same way, so the hiddenness of Congo wildlife is not just a matter of bad visibility, it is partly produced by the animals themselves through the ecological work they do. The elephant helps build the forest hides the elephant. It is the sort of circular arrangement the Congo seems to enjoy. Then there are the gorillas, which sit oddly in the public imagination. People know the word gorilla, and familiarity has a way of making animals feel more available than they are. Yet WWF notes that western lowland gorillas inhabit some of the most dense and remote rainforests in Central Africa, and that exact numbers are difficult to know for that reason. The word remote in this context is doing a great deal of work. Remote does not merely mean far from a road, it means forests with low visibility, difficult movement, limited repeated survey access, and conditions in which counting, tracking, and long-term monitoring become demanding tasks. So even with charismatic megafauna, even with species that make it into documentaries and fundraising posters, the Congo keeps a large part of the day-to-day reality out of view. These animals are there, that is not in doubt. The difficulty is that there can be a very stubborn place. The birds behave similarly. The Congo peafowl, for instance, is endemic to the Congo Basin, and BirdLife notes that it has a small population suspected to be in decline because of hunting and habitat loss. It is one of those birds whose very existence sounds like someone misheard another species and refused to correct the mistake. A peafowl in Central African forest, endemic to the Congo, perfectly real, but not easy. Ground-dwelling forest birds are often difficult to survey, especially in dense tropical habitat where calls can be heard long before a clear view is possible, and where patches of suitable terrain may be isolated by rivers, human pressure, or habitat change. The Congo peafowl is a useful reminder that even among birds, which people often imagine as conspicuous by default, the basin contains species that are better known by traces, reports, and persistence of habitat than by regular casual sighting. If the forest animals are elusive in one way, the river animals are elusive in another. Britannica's overview of Congo River animal life notes that numerous fish species live in the waters of the Congo, that more than 230 species have been identified in Malibo Pool and incoming waters alone, and that riverine swamps host lungfish able to survive dry periods buried in mucus cocoons. It also mentions black catfish in wooded marshlands, where the water is dark like black tea, the fish assuming the colour of their environment. Those details matter because they show how the basin's aquatic life is tied not only to the main river channel, but to swamps, floodplains, side waters, and seasonal habitats where survival depends on doing odd and practical things. In a simpler river system, fish might be imagined as inhabitants of one open corridor. In the Congo, they're residents of a much more varied wet world, and many of them are adapted not to visibility but to obscurity. And then, of course, there is the lower Congo, where the river becomes such an extreme hydraulic environment that the fish begin to look like evidence from another planet. The American Museum of Natural History has described the lower Congo as the deepest river in the world and one of the fastest, with more than 300 known fish species in that final stretch and around 90 endemic to it. That alone is extraordinary. A relatively short part of one river, made hydraulically violent by depth, turbulence and submerged structure, has become a hotspot of endemic fish diversity. AMNH explains this partly through the river's powerful internal currents, which separate fish populations much the way land barriers separate terrestrial animals. The river is open water to us. To many fish, it contains walls. That is one of the most useful and unsettling truths in the whole Congo story. Seen from a boat, the channel looks connected. Lived from within, it may be broken into neighbourhoods by force. One of the strangest inhabitants of that hidden underwater world is Lamprologus lathops, the blind cichlid endemic to the lower Congo. A genomic study published in 2020 found that the species is the only known blind cichlid, and that available evidence suggests it inhabits deep, low-light habitats in the lower river. The paper also notes that genes related to eye formation and pigmentation show inactivating mutations, consistent with adaptation to that dim environment. AMNH's more recent reporting adds that the lower Congo's exceptional speed, turbulence and depth help explain why such unusual fishes evolved there in the first place. This is exactly the kind of animal that makes the phrase seen and unseen feel less like decoration and more like geology and water pressure written into flesh. The river is so deep and the habitat so hard to access directly that one of its best known unusual fishes is quite literally adapted to life where sight is of little use. There is something especially Congo-like about that arrangement. In many places, unseen animals are simply shy or nocturnal. Here, unseen can also mean deep, pressure-influenced, and living in hydraulically segregated habitats we sample only indirectly. Some lower Congo fish are known from individuals brought to the surface under extreme circumstances, and researchers have noted decompression damage in specimens thought to come from deep water. That means the river's hidden biodiversity is not just hidden by forest cover or poor lighting. It is hidden by the physical structure of the water column itself. The unseen, in this case, is not metaphorical. It is literally below the reach of ordinary observation in a river so forceful that simply getting clean samples can be a challenge. Even where species are better known, the basin continues to produce surprises. WWF's 2024 report on new Congo Basin species highlights not only plants and invertebrates, but newly identified vertebrates including a monkey locally known as the lesula and a slender-snouted crocodile among the report's examples. The point here is not that every week the basin produces some carnival-like new beast, but that major terrestrial and freshwater organisms in this region have remained underdescribed well into the modern era. That is the biological consequence of difficult access. Large wet forests, complex river systems, and uneven scientific coverage create enough room for the obvious to stay unnoticed for longer than one might think possible. A monkey can be known locally before the wider scientific world settles on its place. A crocodile can remain wrapped up in taxonomic uncertainty. The unseen is not always tiny. Sometimes it is merely living in a basin big enough to outweight our paperwork. The more familiar riverbank species, meanwhile, can lull people into forgetting how layered this fauna really is. Britannica notes crocodiles, hippopotamuses, otters, ducks, herons, storks and pelicans among the Congo's animal life. Those are the species that fit more comfortably into the mental category of river wildlife. They stand, float, bask, surface or fly in ways humans notice. They are not unimportant. They are simply the visible fraction. If you watch a broad river long enough, you will tend to remember the larger surfaces of life first. The bird lifting from reeds, the hippo in the shallows, the reptile on a bank. What is easier to forget is that beneath those visible signs lies an enormous quieter census of fish, amphibians, invertebrates, swamp specialists, nocturnal mammals, canopy dwellers, and species known only from restricted forest blocks or certain hydrological conditions. The Congo does not lack visible animals. It simply contains so much more than visibility is willing to show at once. This is one reason the basin keeps requiring humility from outsiders. If you arrive expecting spectacle on command, you will likely be disappointed, bitten, damp, and educated in roughly that order. The Congo is full of life, but it is not arranged for convenience. Bonobos occupy remote forests south of the river. Okapi live in dense rainforest. Forest elephants move through habitat that is difficult to survey and are themselves ecologically transformative. Gorillas occur in dense and remote forests where counting them is hard. The Congo peafowl remains elusive in understory habitat. The lower river fish include endemic species adapted to currents and depths that keep them out of easy reach. The basin has, in other words, an abundance of animals and a shortage of theatrical manners. There is also a conservation lesson folded into all this hiddenness. Animals that are hard to see are often hard to protect for the simple reason that protection depends on evidence, monitoring, and repeated presence. UNESCO notes ongoing threats in the Okapi Wildlife Reserve, including insecurity, poaching, and illegal wildlife trafficking aggravated by armed groups and illegal mining. WWF species and park pages emphasize the pressure on bonobos and other Congo Basin wildlife from habitat loss and human disturbance. When a landscape is difficult to enter and its species are difficult to count, conservation can end up fighting with partial information. You know something precious is there. You know threats are operating. You may not always know enough, fast enough, about changing numbers or shifting distributions. The basin's hiddenness therefore protects and endangers at the same time. It shields creatures from easy observation, yet it also slows the flow of knowledge needed to protect them effectively. And still, despite all that difficulty, the Congo keeps offering glimpses. A fish unlike any expected in a deep current. A bird once thought almost impossible to find in the wild, an okapi in the understory, a bonobo call in forests south of the river, evidence of elephants shaping tree regeneration. A new species report large enough to remind the world that hiddenness is not the same thing as emptiness. That may be the most important adjustment of all. When people imagine unexplored places, they often imagine blankness. The Congo is almost the opposite. It is crowded with life. The challenge is not absence. The challenge is density, wetness, distance, and the way the basin allows so much of its life to remain partial to us while still being fully occupied in itself. So when we say the creatures of the Congo are seen and unseen, we do not mean that some are real and some are rumours. We mean that the basin is arranged in layers of exposure. A few animals stand on the edges of human attention. Many remain behind leaves, behind floodwater, below dark surfaces, inside remote forest blocks, or inside taxonomic uncertainty that has not yet been cleared. Some are famous yet still incompletely known. Some are newly described. Some may be present in museum drawers, local knowledge, or camera trap records without yet forming part of a neat public picture. And that is exactly what one should expect from a river basin this large, this forested, and this hard to enter consistently. A place that resists exploration at the level of water, bank and transport is almost certainly going to resist it at the level of wildlife too. which means that once the animals have been accounted for, or at least as far as they agree to be, the next difficulty is waiting in plain view. Because a river like this is never only a natural puzzle, it is also a human one, shaped by distance, conflict, fragile access, and the uncomfortable truth that reaching a place and sustaining work, there are two very different achievements. By the time the river has hidden its depth, its fish, its flooded margins, and much of its forest life, another truth begins to press in. The Congo is not only hard because of water and jungle, it is hard because human access itself is uneven, fragile, and often interrupted. That sounds obvious at first, almost too obvious to be interesting. Of course, hard places are hard to reach. But in the Democratic Republic of the Congo, the issue is larger than inconvenience. The country's transport network has been described by the World Bank as one of the sparsest and most dilapidated in the world, with major connectivity gaps and bottlenecks, and with the Congo River still functioning as the backbone of a multimodal system built long ago for extraction rather than broad territorial integration. When a country of continental scale depends so heavily on a transport spine that is itself difficult, the river stops being just a natural problem and becomes part of a much wider national one. Distance is the first part of that problem, and distance in the DRC does not behave politely. The World Bank notes that in many parts of the country travelling to Kinshasa by road is impossible, and that many provincial capitals are unconnected to the capital by road. In some parts of the country, especially where roads have deteriorated badly or never existed, river transport becomes the only practical means of travel. That is a very different situation from the one people often imagine when they think about exploration. They picture a remote site to be reached from a functioning base. Here, the base itself may be weakly connected. The route in may be mostly riverine. The return may depend on seasonal conditions, port bottlenecks, and the health of a transport system that was never built to serve the full needs of the country in the first place. That dependence on the river can sound almost helpful, as though a great navigable waterway solves the problem it creates. In some respects, it does. The DRC has more than 25,000 kilometres of waterways, one of the largest inland navigable networks in the world, and the river system remains vital for long-distance transport. The World Bank notes that cities such as Kisangani and Mbandaka are connected to Kinshasa only by river transport, and that for long distances the river system is essential because the road network is too incomplete. But the same analysis also notes that river transport is often hampered by silting, long wait times at ports, poor infrastructure and uneven governance. So the river becomes both lifeline and last resort. It works not because it is simple, but because other networks may fail even more completely. That is not a stable platform for sustained scientific work. It is a warning that every expedition, survey campaign, or conservation mission is entering a system where the route itself may already be under strain. Even where navigation exists, access remains brittle. The 2024 International Hydrographic Organization Technical Visit Report on the DRC emphasizes that there is no multimodal transport project in the Congo Basin that does not include a river component, and that safer, faster navigation depends on better hydrographic knowledge and digital cartography. The same report notes that more than 15,000 vessels use over 25,000 kilometres of waterways in the broad sense, yet it also stresses that conditions still need to be further explored and followed up. That phrase matters. It means that the transport system is busy and significant without being fully secured, fully mapped to modern standards, or fully supported by robust infrastructure. A place can be heavily used and still fragile. In fact, heavy use can make fragility more obvious, because every missing chart update, every shifting sandbank, every weak port facility, and every broken communication link affects not one symbolic journey, but thousands of real ones. This is where access stops looking like a matter of individual courage and starts looking like institutional endurance. The IHO report explains that inland navigation in the basin faces material constraints specific to the area, including weak or absent internet connection during navigation and onboard energy limits that may prevent laptop computers from being integrated on vessels. It recommends smartphone-based applications with downloadable charts that can work offline and allow navigators to report shifting sandbanks, lost aids to navigation, and other changes. That is a practical, intelligent response to local conditions, but it also reveals how delicate those conditions remain. When modern navigation planning has to assume weak connectivity, minimal onboard power, and non-standardized local marking systems, exploration does not fail because no one is clever. It struggles because the entire chain from map production to onboard use has to be redesigned around scarcity and instability. There is also the slower, heavier legacy of neglect. The World Bank has written that decades of conflict and neglect have left the DRC's transport infrastructure severely deficient, and that this deficit reinforces national, provincial, and within-city isolation, while making it difficult to build economic and social cohesion. That sentence could almost stand as a summary of why large parts of the Congo River world remain hard to know thoroughly, not because no one has ever gone there, but because repeated movement, repeated measurement, and repeated maintenance all depend on a larger system staying alive around the river. A single survey mission can sometimes be mounted through sheer effort. A long-term observational program, a conservation network, or a reliable research corridor requires more than effort. It requires dependable infrastructure, dependable institutions, and enough continuity that knowledge can accumulate instead of being constantly rebuilt after interruption. Conflict has been one of the great interrupters. It is important to say this carefully, because the Congo River itself is not one continuous front line from source to sea. The country is too large and too varied for that kind of simplification, but conflict, especially in the eastern DRC, shapes the wider national conditions in which river access, logistics, scientific work, conservation, and humanitarian operations all take place. The World Bank has explicitly warned that frequent conflict in the eastern portion of the country can limit or even negate infrastructure investments there, and that this has to be accounted for when thinking about connectivity. Conflict does not need to sit on every bank of the Congo to affect the river's exploration. It can drain budgets, distort priorities, interrupt transport chains, weaken institutions, displace trained staff, and make parts of the country harder to reach or sustain as bases for longer work. The humanitarian figures give that instability a human scale. OCHA says that nearly 15 million people in the DRC need humanitarian support in 2026, while severe funding shortages mean the response is aimed at only 7.3 million. UNHCR reports that by January 31st, 2026, there were roughly 6.47 million internally displaced people in the DRC, and its country pages describe the crisis as severe, with millions displaced most heavily in eastern provinces. Those numbers are not simply background tragedy in a story about a river. They are part of the access problem. Large-scale displacement changes settlement patterns, stretches transport capacity, redirects attention and money, and makes it harder to maintain the sort of quiet, steady, non-emergency field presence that long-term exploration depends on. In a country carrying that level of humanitarian strain, the competition for safe movement, functioning routes, fuel, staffing, and institutional attention is intense. Humanitarian access itself has become more dangerous in the east. OCHA reported that in eastern DRC, the number of incidents affecting humanitarian actors rose from 37 in January 2026 to 46 in February 2026. And another OCHA report said that since January 2025, a total of 709 incidents affecting humanitarian actors had been reported, with North Kivu the most affected province. Those figures matter because if aid agencies with large logistics systems, institutional backing, and urgent mandates face that level of operational risk, then scientific and exploratory work is not taking place in some protected parallel universe where mobility remains untouched. The broader climate of insecurity spills outward. It alters insurance, route planning, staffing, local partnerships, willingness to deploy, and the basic expectation that people and equipment can move repeatedly without being trapped by the next deterioration. That is why fragile access is not the same thing as total inaccessibility. One can still move, convoys still happen, barges still move, researchers still work, communities still live, trade, fish, and travel. But every one of those actions may depend on conditions that are provisional rather than robust. The ICRC noted in December 2025 that it had helped move disarmed members of the Congolese armed forces and their families from Goma to Kinshasa over a journey of some 2,000 kilometers across the front line. That detail is striking not only because of the conflict, but because of the geography. 2,000 kilometers is already a long way in the abstract. Across a front line, in a country with fragile infrastructure, it becomes something closer to an operating system for uncertainty. That same uncertainty surrounds many kinds of movement, even when the purpose is less dramatic than a neutral humanitarian convoy. The river then becomes tied to a second kind of distance. There is physical distance measured in kilometers, and there is operational distance measured in how many institutions, vehicles, permissions, fuel stops, security judgments, and weather windows stand between a plan and its execution. The DRC's transport network, as the World Bank describes it, is so incomplete that air travel is sometimes the only way to move around the country, despite the huge river system. Yet air access is expensive, limited, and poorly suited to the dense repeated movement of bulky equipment, or the slow patient revisiting required by river science. So the country lives with an awkward transport hierarchy. Roads may fail, air may be too costly or too thinly available, and the river may be essential while still being slow and difficult. Exploration in those circumstances does not happen against a blank map. It happens inside a transport compromise. There is another uncomfortable truth folded into this. Poor access can preserve as well as prevent. The World Bank's 2016 analysis notes that conflict, political instability, and poor infrastructure have acted as a kind of passive protection, limiting deforestation in parts of the DRC. That is an unsettling phrase, but an honest one. Roads do not only bring medicine, schooling, and easier research access. They also bring logging pressure, land conversion, and biodiversity loss. So the human challenge around the Congo contains a tension that never really goes away. Better access could make science, conservation, and daily life easier in many places. It could also open fragile forests faster to exploitation. A road into the basin is never only a road. It is a new argument about what the forest and river will be used for and by whom. That tension helps explain why fragile access is the right phrase rather than simply insufficient access. The system is not static. New roads, corridors, and navigation improvements can help. The World Bank has backed transport and connectivity efforts along river road corridors, and hydrographic bodies are actively pushing better river charting and digital navigation support. But each improvement has to enter a landscape where governance, maintenance, environmental protection, and security are all part of the outcome. A port can be improved and still suffer from weak onward connections. A river chart can be updated and still depend on users with offline devices and enough battery power to operate them. A new corridor can reduce isolation and also create fresh pressure on forests and wildlife. The human challenge is difficult precisely because every solution arrives with side effects. It is also worth remembering that local people do not experience this as a puzzle in the abstract. The World Bank notes that up to 40% of people in forested provinces rely on hunting, gathering, and fishing as their main food sources, and environmental dependence is especially high among poorer households. In many river regions, transport is not about adventure or research. It is about food, reaching market, medicine reaching clinics, families reaching one another, and goods moving before spoilage or rain turns a route into a delay. When a river or a road link fails, it is not just that a map looks less efficient. It is that daily life narrows. Exploration has to be understood inside that lived pressure. Outsiders arrive wanting to know the river better. Residents are often trying to keep life functioning around it under difficult conditions. Those are related goals, but they are not identical, and the difference matters. This also changes how one should think about time. In a well-supported research landscape, delay is often a nuisance. In the Congo context, delay can be structural. Long wait times at ports, weak road links, seasonal silting, non-standardized marking, weak communications, and insecurity all stretch the timeline of any serious effort. One missed transfer can matter. One bridge out on a feeder route can matter. One damaged vessel, one local conflict flare-up, one period of low water, one funding gap, one lost navigation marker can matter. None of these is impressive enough to become legend on its own. Together they form the real texture of fragile access. A river does not remain only partly explored because one giant obstacle blocks the way like a theatrical boulder. It remains partly explored because many smaller vulnerabilities keep interrupting the steady repetition from which deep knowledge is made. So the human challenge is not separate from the river. It is braided into it. Distance pushes dependence onto waterways. Weak roads make the river indispensable. Poor ports and silting make the river slower. Conflict weakens the institutions and infrastructure needed to make access dependable. Humanitarian crises redirect attention toward urgent survival and away from patient long-term study. Digital tools help, but must be redesigned for offline use and low-power conditions. Meanwhile, every improvement in access raises environmental questions, because the same remoteness that frustrates researchers has also slowed some forms of extraction. That is why the Congo is hard to explore in the fullest sense. Not because nobody is willing, and not because nobody lives there, but because natural difficulty and human fragility keep reinforcing one another. By this point, the pattern is becoming clearer. The river is deep, the currents are violent, the banks are wet and alive, the wildlife is abundant and often hidden. The transport system is vital and brittle. The wider country is dealing with immense humanitarian need, uneven infrastructure, and regions shaped by insecurity. Once all of that is laid out, the idea of exploration starts to sound less like a single scientific mission and more like a negotiation among hydrology, logistics, ecology, governance, and human urgency. That is where the next part naturally begins, because the Congo is never only a scientific object waiting to be measured. The moment one looks closely enough, it becomes obvious that studying this river is tangled up with ethics, livelihoods, power, and the question of what exploration is for in the first place. By this point, it would be easy to pretend that the Congo is mainly a technical challenge. Deep water, fast current, flooded forest, weak infrastructure, hard travel, difficult weather. All of that is true, and all of it matters. But it still leaves out one of the biggest reasons the river cannot be treated like a simple scientific puzzle. The Congo is not an empty laboratory. It is a lived corridor, a source of food and transport, a political space, a conservation battleground, a memory of colonial extraction, and a place where millions of people already have reasons to care very deeply about what outsiders come to measure, map, protect, use, or change. Science enters that world. It does not float above it. And once that is understood, exploration here stops looking like a neutral act of curiosity and starts looking more like what it really is, an encounter between knowledge, power, history, and livelihoods. A useful place to begin is with the old habit of calling it exploration at all. That word has baggage in the Congo. Britannica's account of the Congo Free State makes clear that European exploration of the Congo River in the late 19th century was tied directly to political control, treaty-making, transport construction, and the opening of the interior to European trade under Leopold II's private rule. Henry Morton Stanley's river journeys did not end in a quiet library note that said, "Interesting waterway worth future study." They fed a process through which the Congo River basin was claimed, divided and absorbed into one of the most brutal colonial systems in modern history. Railways were built to bypass rapids, stations were founded upriver, steamboat navigation was extended where possible. Exploration, in that historical setting, was never just about finding out what was there, it was part of taking hold of it. That history still matters because rivers remember the uses imposed on them, even when the language changes. UNESCO's account of the Congo River notes that during the colonial period, the river served as the main transportation route for goods exported to Europe, while sections blocked by rapids were linked by rail around the obstacles. So the river was studied, mapped, sounded and traversed, not only because it fascinated geographers, but because it could move commodities. That leaves a long shadow over any later claim that river knowledge is purely scientific. In the Congo, knowledge of the river has often been tied to extraction, administration, shipping and control. Even when modern researchers arrive with very different goals, they do not enter a blank moral landscape. They enter one where local people have seen outsiders come before, with plans, instruments, and assurances that the larger purpose was reasonable. That's one reason present-day researchers working in the basin increasingly speak so openly about equity, local leadership, and trust. A 2020 synthesis on capacity building in the Congo Basin argued that effective research funding should invest in research in the Congo, not merely research about the Congo, and that such work must increase local research capacity through equal partnerships. The authors go further and say international scientists must recognise their unfair advantage in resources and opportunities, respect partners as knowledge holders rather than field assistants, and remain conscious of how colonial attitudes still shape outside approaches to the region. That is not the sort of language people use when science is simply about water depth or species lists. It is the language of a place where knowledge itself has politics attached to it, and where doing good science means paying attention to who asks the questions, who owns the data, who receives the training, and who gets left behind when the paper is published. The same lesson appears in the Royal Society's case study on the SEA-UHM consortium, which studied Congo River hydraulics and morphology. The project was built not only to improve scientific understanding, but also to meet stakeholder needs in navigation, water resource management, flood risk, and local development. The consortium worked with river authorities, communities, and government agencies from the start. Local needs shaped the research framework. Communities were trained to care for gauging stations. Local logistical support was described as essential. The team had to learn how to negotiate trust with communities used to foreign visitors coming for natural resources. That single phrase says a great deal. It means science on the Congo cannot assume welcome, neutrality, or automatic legitimacy. It has to earn those things in a landscape where the memory of outside extraction is not theoretical, and that trust matters because the river's uses are immediate and practical. The Royal Society case study notes that Congo River data are needed not only for academic models, but for navigation, hydroelectric development, irrigation, water supply, sanitation, flood forecasting, and safety. It also reports that of more than 400 river gauges installed in the colonial era, fewer than 10 were operational across the basin, even as demands for river data had grown. The result is that even a project aimed at understanding hydraulics quickly spills into governance, hazard reduction, transport planning, and development strategy. A scientist taking a measurement in the Congo is not merely satisfying private curiosity. The measurement may feed decisions about transport corridors, electricity schemes, flood warnings, or riverbank management. In that setting, just science is not a stable category. The data are already entangled with public consequences. There is another layer as well, and it involves the people who live in and around the basin. UNESCO says the conservation of Congo Basin forests is essential for 30 million inhabitants who depend on the environmental products and services those forests provide. The World Bank's 2026 Congo Basin Forest Economies Programme goes further, saying 60 million people live in or near the forest areas and directly depend on them for livelihoods, including local communities and indigenous peoples from at least 150 ethnic groups. When that many people are tied to the basin for food, shelter, culture, transport and income, no serious exploration can pretend the place is mainly an object of outside study. Every survey line, protected area proposal, navigation update, carbon plan, hydropower design and biodiversity project lands inside a region where people already have claims, uses, histories and vulnerabilities. Science does not replace that human reality. It enters into negotiation with it. That becomes especially clear in conservation, which many people assume must be the cleanest and least controversial form of scientific engagement. It is not. UNESCO's Congo Basin World Heritage materials show that the region's biodiversity is globally significant, that 9 natural properties in the Congo Basin are on the World Heritage List, and that 4 sites on the list of World Heritage in danger are all in the Democratic Republic of the Congo. UNESCO also runs a program explicitly called Biodiversity Conservation in Regions of Armed Conflict, aimed at protected areas in the DRC. That title alone should settle the matter. In this region, conservation cannot be separated neatly from conflict, state capacity, armed violence, or local survival. A protected area is not simply a biological box on a map. It is a piece of territory where questions of access, authority, livelihoods, and security are alive all the time. Once conservation enters the picture, local rights enter with it. A 2025 World Bank press release about carbon payments in Mai-Ndombe says the distribution plan is designed to share benefits fairly among local communities, indigenous peoples, customary authorities, and other local partners, with attention to forest-dependent and vulnerable groups such as women and youth. The reason that kind of language matters is simple. It recognises that forests and river landscapes are not just reservoirs of carbon or biodiversity for outsiders to value. They are places where benefits and burdens have to be distributed among people already living there. If a project studies the river, protects its basin, or monetises avoided deforestation, somebody will gain, somebody will bear restrictions, and somebody will reasonably ask whether science and conservation have once again become new names for old patterns of external control. This is where the idea of the field site starts to break down. A field site sounds temporary, technical, and slightly tidy. The Congo is none of those things. The World Bank's 2026 Regional Forest Programme says the basin's sustainable development must create jobs, strengthen value chains, and improve livelihoods for the 60 million people living in and around the forest, who have long been bypassed by growth. That is a striking phrase too. Bypassed by growth. It reminds us that many communities in the basin have already watched global systems take interest in their land, timber, wildlife, minerals, and transport routes without reliably delivering broad local prosperity in return. So if science arrives and says it now needs access for river gauges, biodiversity monitoring, conservation zoning, or hydrological models, the natural response is not necessarily excitement. It may be caution, not because knowledge is unwelcome in itself, but because people have seen interest in the Congo attach itself to other people's priorities before. The practical conduct of research reflects this. In the Royal Society account, even installing river gauges required bringing together communities and river users through local chiefs, explaining the purpose of the equipment and training people to care for it. The same stakeholder process surfaced concerns that were not originally central to the scientific agenda, including flooding, water quality, pollution-related health impacts, unmonitored deforestation, and bank erosion.
That is a very useful corrective to the fantasy of purely objective field science. Researchers may arrive with one list of questions. The people living by the river often have another. If the science is to last, those lists must meet somewhere. The river can be measured in cubic meters per second, yes, but to nearby communities, it may also be a source of drinking water, transport, erosion risk, flood damage, or fishing pressure. A study that ignores those concerns may still produce data. It will not produce trust, and in the Congo, trust is part of the infrastructure. There is also the matter of state weakness and instability, which change the ethics of doing research in subtle ways. The Royal Society case study notes that hydrological knowledge of the Congo is lacking in part because of decades of instability in the DRC, difficulty transporting equipment along seasonally navigable channels, and the limited number of African institutions that have been able to gather and analyze river data. That means international researchers do not arrive in a vacuum of equal capacity. They arrive in a setting where instability has already thinned institutions, interrupted measurements, and made advanced tools harder to sustain. Under those conditions, the ethical question is not just, can we collect the data? It is also, who will be able to keep collecting it when we leave? If a project extracts information but leaves little durable local capacity behind, the imbalance reproduces itself.
The colonial echo is hard to miss there. The old model was simple enough. The interior is studied, the routes are charted, the samples and value flow outward, and the centre of interpretation sits elsewhere. Modern researchers often reject that model sincerely, but rejection has to be demonstrated in practice. The One Earth article on Congo Basin capacity building says, African scientists need to be at the centre of developing new understanding so that it is not merely wisdom provided from afar and so that it is more likely to influence local policymakers. That is not just a nice institutional aspiration. In a place like the Congo, it is part of the answer to a historical problem. If the river is studied mainly by outsiders, interpreted mainly elsewhere, and fed back into decisions mainly through foreign institutions, then scientific exploration risks becoming another form of asymmetry, even when its language is more polite than in the 19th century. All of this becomes sharper when the science feeds large development choices. River data can shape navigation upgrades, hydropower plans, flood models, or conservation zoning. Those are not neutral downstream uses. They affect land rights, energy politics, transport priorities, and who gets displaced or protected. The Royal Society case study explicitly notes that better river flow measurements and models help navigation authorities predict conditions and update charts, and that the World Bank is interested in flood risk models. That is valuable and necessary work. It is also the kind of work that has consequences beyond the scientific paper. Once science starts informing policy, it enters the realm where some interests align, others clash, and technical knowledge begins to have winners and losers. The river is not just being understood, it is being prepared for decisions. There is also a global layer to this story, and it complicates matters further. The World Bank's new regional programme describes the Congo Basin forest as the world's second largest tropical forest system, and emphasises its climate importance, while UNESCO highlights the basin's role in carbon sequestration and global climate regulation. In plain language, the world now has reasons to care about the Congo that go far beyond the Congo itself. Carbon, biodiversity, rainfall regulation, and planetary climate all enter the conversation. That global attention can bring funding, urgency, and scientific resources. It can also create another asymmetry, where the basin is valued for services it provides to everyone else, while the burden of restrictions, adaptation, or conservation falls most heavily on local communities. Once again, exploration is not just scientific. It is entangled with the question of whose priorities are being advanced, when the river and forest are studied more intensely. Even protected areas, which seem like the obvious answer to biodiversity loss, sit inside that tension. UNESCO's Congo Basin Material emphasizes management of the whole ecological landscape and notes the importance of conservation in regions of armed conflict. That sounds correct, because it is. But it also hints at the complexity. To protect a landscape, somebody must patrol it, govern it, finance it, define its boundaries, and decide how local use will be regulated. Science can inform those decisions, but it cannot make them painless. A biodiversity hotspot may also be a place where nearby communities need land, fish, fuel wood, or access to riverside resources. The more important a place is scientifically, the harder the political and ethical questions often become. The Congo offers that difficulty in concentrated form, so when people ask why the Congo River cannot be truly explored, one honest answer is that truly turns out to mean more than bathymetry and boats. To know this river in any deep sense, one would have to know its people, its institutions, its conflicts, its conservation fights, its history of extraction, its infrastructure gaps, and the ways local communities understand and use it already.
One would have to accept that a river gauge can be about flood safety, that a fish survey can be about food security, that a conservation map can be about rights, and that a research grant can either build local capacity or repeat a familiar pattern in which knowledge leaves faster than benefits do. In the Congo, science is real and necessary. It is simply never alone. That is why the best recent work in the basin sounds less triumphant than older exploration stories. It talks about partnerships, stakeholders, communities, local needs, training, and long-term capacity. It talks about being conscious of colonial attitudes. It talks about fair benefit sharing. It talks about conservation in armed conflict regions. It talks about jobs and livelihoods, not only protected hectares or elegant models. None of that makes the science weaker. It makes it more honest. The Congo River cannot be understood properly if it is treated as water plus mystery. It has to be treated as water plus people, plus history, plus power, all moving together, sometimes in the same direction and sometimes very much not. And once that becomes clear, the final question begins to sharpen on its own. Because after all the measurements, all the maps, and all the field campaigns, the river still keeps part of itself back.
After all the maps, all the sounding equipment, all the field notes, all the satellite passes, all the species lists, and all the ambitious plans to finally make sense of the river in a proper modern way, the Congo still keeps a surprising amount to itself. That is not because nothing has been learned. Quite the opposite. We know vastly more than people did a century ago, or even a few decades ago. We know the basin is one of the most important hydrological and ecological systems on Earth. We know the lower Congo includes extraordinary depths and extreme hydraulic conditions. We know the basin contains the largest tropical peatland complex on the planet. We know the forests support immense biodiversity and tens of millions of people. We know the river is both lifeline and obstacle. The problem is that knowing all of that still does not amount to full understanding. The closer one looks, the more the river begins to resemble a place where every answer uncovers 2 or 3 new forms of ignorance waiting behind it. One of the things the Congo still keeps from us is completeness. That may sound like an unsatisfying answer, but it is probably the most honest one. A river this large and this varied does not yield a single final portrait. There are major stretches where hydrological monitoring remains too sparse, too inconsistent, or too recent to provide the kind of long, dense record scientists would ideally want. The Royal Society's Congo River case study notes that of more than 400 river gauges installed during the colonial era, fewer than 10 were operational across the whole basin at the time the consortium began its work. That is an astonishing figure when you consider the scale and importance of the river. It means that even before the discussion turns to hidden fish or flooded forests, the very basic question of long-term, evenly distributed measurement has been compromised by years of interrupted monitoring and institutional weakness. A river can only be fully known if it is watched steadily. The Congo has often not been watched steadily enough. That shortage of monitoring matters because large river basins do not merely need snapshots. They need repetition. They need wet years, dry years, average years, flood years, delayed flood years, and measurements taken often enough to show how one part of the basin talks to another over time. The Congo Basin is so large that local conditions are often being shaped by rainfall, storage, and release processes happening far away, and that makes incomplete monitoring especially costly. When the observing network is thin, models can improve, satellite products can help, and field campaigns can reveal remarkable local truths, but there is still a difference between having a sophisticated understanding and having enough ground truth everywhere you would like it. The river keeps from us not only specific numbers, but the kind of confidence that comes from seeing a system behave repeatedly, under many conditions and across many years. The Congo also keeps from us a fully settled picture of its underwater architecture. The lower river has already shocked researchers with depths over 200 metres, high velocities, and hidden relief dramatic enough to make parts of the bottom resemble submerged mountain country more than the gentle bed people imagine when they hear the word river. Yet even those discoveries point to the unfinished nature of the work. The reason those measurements felt so important is that they revealed how much had not previously been measured directly. The river's hidden topography, turbulent structure, and near-bed dynamics are not things one can infer perfectly from the surface. They have to be surveyed, often in physically difficult conditions, and surveyed again if one hopes to build a stable understanding. What the Congo keeps from us here is not merely one dramatic number about depth. It keeps from us the luxury of assuming that the unseen part of the river has already been neatly accounted for. In some places, the river keeps from us direct access to habitats that are almost certainly occupied, but not routinely sampled. The best-known example is the deep lower Congo fish fauna. Research on the blind cichlid Lamprologus lethops indicates that it likely inhabits deep, low-light sections of the lower river, and the American Museum of Natural History has repeatedly emphasized that the lower Congo's violent hydraulics help create a world of biological segregation and odd specialization beneath the visible current. That is deeply revealing, but it is also an admission of limits. We know enough to say such habitats exist and are shaping evolution. We do not yet have the sort of routine, ordinary, unremarkable access that would make those deep habitats feel fully familiar. The river is still keeping part of its biological life in places where our usual ways of looking remain awkward, indirect, or expensive. It keeps from us, too, the full count of what lives there. WWF's 2024 report documenting 742 species identified in the Congo Basin over the previous decade is, on the one hand, a celebration of discovery. On the other hand, it is a reminder that one of Earth's major river forest systems is still yielding new species at a rate that would make any claim of total inventory sound premature. These discoveries include fishes, amphibians, reptiles, birds, mammals, plants, and invertebrates. In other words, the incompleteness is not confined to obscure microbes or one overlooked beetle in a remote patch of moss. It stretches across the visible and the less visible alike.
The Congo still keeps from us the simple satisfaction of saying, with confidence and without embarrassment, that we know what all the major living pieces are. And even where species are already known, the river and basin keep from us a full understanding of how they are distributed and why. The lower Congo's extreme fish diversity appears tied to hydraulic compartmentalization, where powerful currents and deep turbulent channels act like barriers, isolating populations and encouraging divergence. But that explanation, useful as it is, opens wider questions about how many other species across the basin are being shaped by fine-scale environmental boundaries we have not yet mapped clearly enough. In a forested river system full of swamps, side channels, floodplains, dark waters, rapids, and seasonally shifting margins, distribution is not a simple matter of drawing a range on a map. The Congo still keeps from us a satisfying one-to-one match between species lists in the exact ecological mechanisms organizing them in space. Then there are the wetlands and peatlands, which may be among the basin's greatest experts in the art of partial concealment. The central Congo peatlands were only field verified and mapped in a major way within the last decade, and they turned out to be the largest tropical peatland complex on Earth, with enormous carbon stores.
More recent reviews emphasise that there are still substantial unknowns about their hydrology, biodiversity, vegetation communities, and the way water moves between river channels, floodplains, interfluvial wetlands and peat domes. That is an extraordinary sentence to have to keep writing in the 21st century. It is one thing for a small marsh in a neglected corner of the world to remain poorly described. It is another for a globally significant peatland system in the Congo Basin to remain only partly characterised because it is so wet, so large, and so hard to enter consistently. The basin keeps from us not only species and measurements, but the full hydraulic logic of one of its most important wetland landscapes. Those peatlands also keep from us a fully settled forecast of the future. A 2025 NPJ Climate and Atmospheric Science study reported persistent drought conditions in the Congo River basin and stated plainly that their drivers and impacts on basin hydrology remain unknown. A 2025 study on land use change and Congo peat carbon warned that large-scale drainage or prolonged lowering of the water table could trigger major carbon losses, while also stressing the urgent need to understand future rainfall in the basin well enough to know whether the region is more likely to become wetter or drier. Put more simply, the basin is globally important, climatically sensitive, and still not understood well enough to give the comfortable predictive confidence people often want from environmental science. The Congo keeps from us not only present detail, but part of the future as well. There is something a little unnerving about that. We are used to thinking that science steadily reduces uncertainty until the remaining unknowns become small and well-behaved. The Congo suggests a different pattern. In some systems, every improvement in measurement exposes the true size of what remains unresolved. Better mapping of peatlands reveals that their water dynamics are more complex than expected. Better measurement of the lower river reveals that its flow structure is more hydraulically segmented than expected. More biodiversity surveys reveal that the species inventory is less finished than expected. More climate work reveals that hydrological vulnerability is harder to predict than expected. The river and basin do not simply hand over secrets one by one and become tamer, they reveal themselves by deepening the problem. Another thing the Congo keeps from us is the ease of synthesis. There is now a great deal of knowledge scattered across hydrology, geomorphology, fish evolution, forest ecology, peatland science, conservation, satellite remote sensing, transport studies, and local practical expertise.
The challenge is that these kinds of knowledge do not automatically click together into one perfectly integrated picture. Satellite data can show water propagation and flood extent, but not every fine-scale process within channels or beneath forest canopy. River gauges offer direct observations but are sparse. Biological surveys can reveal extraordinary endemism, but only in sampled reaches and sample seasons. Local communities know the working river intimately, but their knowledge may not arrive in the same format as academic data products. The Congo keeps from us the tidy synthesis our minds crave, because the basin is so large and the knowledge types so different that integration remains a project rather than a finished state. It also keeps from us the comfort of thinking that remoteness automatically protects what is hidden. This is perhaps one of the saddest things the basin withholds. A place can remain incompletely known and still be increasingly vulnerable. The peatlands are considered mostly pristine, yet recent work shows they are vulnerable to drainage, drying, and land use change. The forests remain biologically rich, yet many of the newly identified species in the WWF report are already under pressure from human activities. The river retains hidden habitats, yet pressure on transport, development, conservation areas, and surrounding land use continues. So the unknown is not safely frozen in place, waiting for us to become wiser?
Some of it may be changing while we are still trying to describe it. The Congo keeps from us the reassuring sequence in which knowledge comes first and damage later. In many cases, both are happening at once. And then there is the more human kind of unknown, which may be the hardest to admit. We still do not fully know what the right future relationship between people and this river should look like. Better charts and hydrographic data can make navigation safer. Better river monitoring can improve flood forecasting and water management. Better conservation science can help protect wildlife and carbon-rich wetlands. Better infrastructure can reduce isolation. Yet every one of those good and sensible ambitions also creates trade-offs. Greater access can mean greater extraction. Better protection can mean new restrictions on local use if done badly. More global attention to the basin's carbon value can bring resources, but also outside priorities. The Congo keeps from us a simple moral formula in which exploration, protection, and development all line up without friction. They do not. They have to be negotiated, and the negotiation remains unfinished. That unfinished quality reaches even into the language people use. One might be tempted to say the Congo still keeps its mystery, but mystery can sound decorative, as though the river were politely cultivating intrigue for our intellectual entertainment. The truth is more grounded than that. What it keeps from us are very practical things: complete time series, full bathymetric coverage, full taxonomic inventory, routine access to deep habitats, settled forecasts of hydrological change, dense monitoring across flooded forest and peatland, and a conflict-free, infrastructure-rich environment in which all of this could be studied steadily for decades. The unknowns are not misty in the romantic sense. They are gaps in observation, gaps in access, gaps in integration, and gaps in our ability to return often enough, safely enough, and patiently enough to turn fragments into wholes. Still, it would be wrong to make the river sound unknowable in some grand absolute way, as though it existed outside science altogether. That is not the lesson. The lesson is narrower and perhaps more useful. The Congo is knowable in pieces, increasingly so, sometimes brilliantly so, but resistant to closure. Every advance matters. Every new gauge, every better chart, every improved wetland map, every carefully sequenced fish genome, every field season that returns with good data, every local partnership that lasts, every species description, every flood monitoring improvement, all of it matters. But the basin as a whole still withholds finality. It does not give us the satisfying last page where the expert closes the notebook and says, "There, done." The Congo keeps from us that kind of ending, and perhaps that is part of why the river continues to exert such a hold on the imagination, even after one has stripped away the clichés and the old feverish language. It is not because it is empty. It is because it is full and still partly unresolved. Full of water and hidden force, full of peat and carbon, full of fish and forest animals, full of roots people depend on, full of lives lived beside its banks, full of measurements still needed, full of futures still unsettled. The Congo keeps from us the illusion that one more expedition, one more instrument, or one more generation of technology will necessarily turn a living basin into a completed object of knowledge. Some places are simply too large, too active, too layered, and too human for that. So when we say the Congo still keeps things from us, we are really saying something very ordinary and very humbling. We are saying that the river remains ahead of us in important ways, ahead of our monitoring, ahead of our models, ahead of our species inventories, ahead of our ability to separate science from politics or discovery from responsibility. That does not make the effort pointless. It makes the effort honest. It means that to approach the Congo properly is to accept that the work is ongoing, the picture incomplete, and the river under no obligation to become simple merely because we would find that convenient.
And once that is admitted, the final step is not to force a heroic conclusion, but to sit for a moment with what that says about rivers, knowledge, and the very human wish to feel that everything important can eventually be pinned down if we just keep pushing a little farther.
And so we arrive at the point where the river stops needing to prove anything. It has already shown enough. It has shown that a line on a map can be honest, and still wildly incomplete. It has shown that a river can be enormous, economically central, biologically rich, and still resistant to full human understanding. It has shown that modern tools help, but do not cancel depth, current, floodplain, forest, conflict, weak infrastructure, or distance. It has shown that even now, basic long-term observation across the basin remains thinner than a place of this importance really deserves, with major efforts in recent years still having to rebuild hydrological knowledge in a basin where fewer than 10 of the more than 400 colonial-era gauges were still operational when one major research effort began. That, perhaps, is the first reason the Congo feels different from many other great rivers. Not because it is untouched, not because no one knows it, not because it exists outside science or history. It feels different because the usual human sequence never quite completes itself. We find a place, we map it, we measure it, we return to it. We make the unknown smaller. We turn difficulty into routine. We fold a hard landscape into schedules, charts, institutions, and dependable systems. Much of the modern world runs on that sequence. The Congo keeps interrupting it. Not absolutely, but often enough to matter. Every time the picture begins to look satisfyingly complete, something important remains outside the frame. Part of what remains outside the frame is simple scale. The Congo Basin supports an estimated population of more than 157 million people across 6 countries, and some 60 million rely directly on its forests for food, medicine, materials, and shelter. That alone should change how one hears the phrase remote wilderness. This is not an empty backdrop for adventure. It is a lived region, a working region, a region carrying human dependence at enormous scale. At the same time, the World Bank is now describing the basin as a place where new programs are being built around jobs and sustainable forest economies for roughly 60 million people living around it, which tells you that the future of the Congo is still very much an open practical question, not a finished one. That human reality is one reason the river cannot be fully entered in the old heroic sense. You cannot simply go into a place like this as though it were waiting for your arrival to begin existing properly. People already live there, work there, travel there, fish there, negotiate there, and endure there. The river is already part of ordinary life on a scale that outsiders often underestimate. So when we say we cannot fully enter it, what we really mean is that we cannot reduce it to our own terms. We cannot turn it into a neat object that begins with our curiosity and ends with our explanation.
The Congo is too inhabited for that, too used, too consequential, and too entangled with everyday needs. It is also too burdened by history. That history does not sit on the river like an old plaque no one reads anymore. It is woven into the way knowledge, access, extraction, and outside attention still behave. The Congo Basin remains one of the most important natural regions on Earth, and UNESCO has spent decades trying to strengthen conservation there, including in sites in the Democratic Republic of the Congo that have faced danger linked to armed conflict. UNESCO's work in the region has explicitly included biodiversity conservation in regions of armed conflict, which is not the sort of phrase anyone uses for a place that can be approached as a clean scientific field site. That matters because a river becomes harder to know when the institutions around it are under pressure. It becomes harder to revisit, harder to monitor steadily, harder to protect, harder to compare across years, harder to fund patiently, and harder to approach without every effort becoming part of some larger political or humanitarian reality. The Congo does not need every bend of water to be dangerous for instability to affect the whole story. It only needs enough interruption, enough weak infrastructure, enough conflict in key regions, enough administrative strain, enough broken continuity, and enough scarcity that knowledge keeps being made in fragments rather than as one smooth, cumulative record.
And yet, even with all that, the river is not only a story about limitation. There is another way of understanding what the Congo still refuses to surrender. It is not merely withholding facts, it is preserving proportion. It keeps reminding us how large a real place can be compared with the systems we bring to organise it. We are used to environments that eventually yield to standardisation. We like graphs that thicken into certainty, routes that become dependable, inventories that begin to feel closed, and digital maps that calm us with the quiet implication that the world is now mostly under control. The Congo continues to deny that comfort in important ways. It says, in effect, that there are still places where the map can improve while the whole remains unfinished, where the data can grow while the understanding remains partial, where the river can be used every day and still not be fully known. There is something healthy in that, even if it is inconvenient. It is healthy because it forces a more honest idea of knowledge. Not the old performance of mastery, where the explorer arrives, the mystery disappears, and the audience is invited to admire the complete result. The Congo encourages a less flattering and more mature version. Knowledge here is collaborative, interrupted, local, partial, technical, historical, and slow. It comes from fish surveys, boat crews, river communities, hydrographers, elders, satellite analysts, conservationists, field biologists, cargo operators, hydrologists, and people whose names never make it into documentaries but whose practical judgment keeps work from falling apart. It comes in layers, not in one triumphant reveal. That is why calling it the last great river we cannot fully enter should not be mistaken for saying it is forbidden or empty or beyond all understanding. It is not. People enter it constantly. People depend on it constantly. Scientists study it. Pilots cross above it. Barges move on it. Communities know stretches of it with deep practical intimacy. What we cannot fully enter is the whole of it at once. We cannot step into the Congo and expect all its scales to open together. The local and the basin-wide, the human and the hydraulic, the visible bank and the hidden floodplain, the surface current and the deep channel, the species we know and the species still turning up, the transport route and the living forest, the map and the soaked reality. Those things do not line up neatly enough for total entry in the way our language would like, and perhaps that is exactly why the river continues to matter. Not only because of what it contains, though it contains an enormous amount. Not only because of what it supports, though it supports millions of lives and one of the most important forest systems on the planet. Not only because of what it does for climate, biodiversity, rainfall and regional transport, though it does all of that. It matters also because it is one of the clearest remaining examples of a place that still resists the flattened, finished feeling of modern knowledge. A place where there is still room for surprise without needing to invent myths. A place where humility is not a decorative moral at the end of the story, but a working requirement from the beginning. That humility is not defeat. It is just proportion. We can know more. We should know more. Better gauges, better local partnerships, safer navigation, stronger conservation, fairer sharing of benefits, longer records, better protection for communities and habitats. All of that matters. More knowledge would save lives. It would improve forecasting, transport, ecological protection, and policy. It would help people who already live with the river's moods every day. None of this is an argument for leaving the Congo vague and romantic. Vague and romantic has often been a very lazy way of looking at Africa. The point is almost the opposite. The river deserves patient, grounded, technically serious understanding. It simply deserves that understanding without the old arrogance that mistakes progress for completion. Because completion is the one thing the Congo still seems unwilling to provide. And that may be the quiet truth sitting beneath everything we have covered. We do not only want knowledge, we want closure.
We want the sense that the important places of the Earth have now been more or less settled into our systems, that the blanks are gone, the edge cases cataloged, the routes charted, the problems measured, and the future largely reduced to management. The Congo continues to resist that emotional reward. It gives information, but not closure. It gives access, but not easy access. It gives scientific findings, but not final synthesis. It gives maps, but not a stable sense that the map is now enough. It gives us proof of immense ecological and human importance, while also reminding us that importance does not guarantee clarity. So perhaps the most honest closing is not to say that the river defeats us. That sounds too dramatic, and it gives us a starring role we have not earned. Better to say that the Congo keeps us in our place. It keeps us aware that a river can still be larger than the categories prepared for it. Larger than transport corridor, larger than biodiversity hotspot, larger than hydrological system, larger than development challenge, larger even than scientific frontier, because each of those phrases is true and each is still too small. It is at once all of those things and more ordinary things too. A place where people wake up, work, repair engines, paddle canoes, wait for cargo, worry about floods, watch river levels, fish in side channels, cross to family, cook meals, and negotiate with whatever the season is doing.
The grandness of the Congo should never be allowed to erase the daily life beside it. If anything, that daily life is part of what makes the river so difficult to summarize. Great systems are never only great in the abstract. They are also exhausting, useful, fragile, political, muddy, expensive, and very often late. There is something almost comforting in that. Not comforting in the sense of easy, of course. The Congo is not easy, but comforting in the sense that it still asks us to be serious. It still refuses quick interpretation. It still forces a slower pace of thought. In a world that likes instant visibility, instant response, and instant certainty, the Congo remains stubbornly on river time, forest time, flood time, repair time, return trip time. It will let you learn from it, but it does not hurry for your convenience. There are probably worse teachers. And so, as we drift toward the end of this long look at a river that never really fits inside one look, we come back to the simple question underneath all of it. Why can't we truly explore the Congo River? Not because no one has gone there, not because it is blank, not because it is beyond science, but because true exploration, if we are being honest, would require more than a route and more than a reading. It would require full, durable, repeated entry into all the layers at once. The water, the hidden bed, the floodplain, the forest, the wildlife, the communities, the institutions, the history, the politics, and the future pressures already moving toward it. And that kind of entry is still beyond us. Not forever, perhaps, in every respect. But enough beyond us still that the river remains one of the last places on Earth where human knowledge is forced to proceed without pretending the work is nearly done. If anything, the wisest response to the Congo may be a quieter ambition, not to conquer it in understanding, not to force it into a final summary, not to speak of it as though it were waiting to be finished, only to keep learning it carefully, to keep measuring where measurement helps, to keep listening where local knowledge already runs deeper than outside assumptions, to keep protecting what can still be protected, and to keep resisting the temptation to turn difficulty into myth, when in fact it is made of very real things: water, forest, infrastructure, conflict, labour, weather, time. That is enough. More than enough, really, and maybe that is why the river lingers in the mind after the facts have settled. Not because it is unknowable, but because it remains appropriately large. Large enough to stay partly ahead of us. Large enough to make certainty feel a little cheap, large enough to remind us that there are still places where knowledge must remain respectful if it wants to remain true. So, wherever you're listening from tonight, whether the hour is late or merely pretending to be, I hope this slow journey through the Congo has given you something peaceful to hold on to. Not a neat conclusion, perhaps, but a steadier one. The Earth is still bigger than our summaries. Some rivers still refuse to be turned into simple stories. And the Congo, broad and dark and busy and stubborn, continues to move through the middle of that truth. If you found this gentle deep dive calming, interesting, or simply a good companion for the evening, I'd be very grateful if you liked the video, subscribed, and shared this sleepy little corner with someone else who might enjoy drifting off inside a difficult question. For now, though, there is nothing left to solve tonight, only the river still moving, and you a little farther along than when we began.